Good morning. Here I am again, Kai Arne, the CEO of the MariaDB Foundation. And I'm welcoming you to the third day of the New York MariaDB Server Fest 2020. This day will start by one of the highlights, Marko Mäkelä. He will be talking about the latest features of InnoDB in MariaDB. So, scalability improvements in MariaDB's InnoDB storage engine. Looking at the last versions of MariaDB when it comes to InnoDB functionality. He will be followed by Krunal Bauskar, MariaDB on R. That's a red presentation, red meaning it refers to hardware integration of MariaDB with some platform, and in this case the very topical ARM platform, which figures in the news for other reasons today. He will then be followed by another MariaDB Foundation presenter. Our board member Sergey Golubchik will take a look at the roadmap starting from 10.5 and going then beyond what is in store for MariaDB. After that, Jorge Torres. It's about machine learning. So AutoML in MariaDB, train and query machine learning models straight from MariaDB. Very interesting topic to be talking about machine learning and how it's best integrated into MariaDB. An open source project, AutoML. After that, I'm excited to have a MariaDB Foundation guy present an idea that we've been working on for a couple of months. It's Robert Bindar, and the project is Jupyter. So integration of MariaDB into Jupyter so that you can query your MariaDB database in an environment that is familiar to many of you, meaning Jupyter. Bringing MariaDB closer to the data science community, the MariaDB Jupyter kernel. And after that, another highlight of this conference, Ask Me Anything with Monty. And if you know Mikael Widenius, the founder of MariaDB, you know that anything means anything. So let's see what kind of questions you have had in store for him and what you will ask interactively. He will be followed by a yellow presentation, user experiences and user experiences of the key feature of MariaDB 10.5, meaning column store, which has been integrated as a complete storage engine in MariaDB 10.5. Building a relational data lake with MariaDB column store. After that, we have one of the other key topics of this conference, which is migration. And this is a collection of migration tales by Shiv Iyer. And this day and the conference is concluded by a talk on innovation by MariaDB Foundation's very own Daniel Black. Innovation here refers to anything from bug reports, which actually is a form of innovation if you properly work within the ecosystem so that the community can contribute towards the QA, quality assurance of the product, to new feature requests on Jira. How does the MariaDB Foundation work in order to have a functioning ecosystem? He sees our role as that of a diplomatic service. So looking forward to see what he has to say about that. And also about CI, continuous integration, how to not just do a quality assurance of MariaDB on several platforms or on the platforms that MariaDB is running, but also of the community products that then need to take into use what the innovations that have been built into MariaDB. So that concludes day 3 out of the MariaDB Server Fest 2020. Let's now get going. The next presenter is the core developer from MariaDB Corporation, Marko Mäkelä, Scalability Improvements in MariaDB's InnoDB storage engine.
Hello, my name is Marko Mäkelä. I have been working on the InnoDB storage engine for 17 years. I finished my doctoral thesis on concurrent systems on model checking, and I joined InnoBase, the subcontractor of MySQL, in 2003. It was acquired a couple of years later by Oracle, and almost 4 years ago I joined MariaDB and have been involved with development of InnoDB storage engine in MariaDB since then. Today I will talk about scalability improvements that we have done in the MariaDB server, mostly in the 10.5 release. So as a user of a database, you must be aware that transactional logs are something that you control. So the data architecture should be such that you minimize logging conflicts and deadlocks due to transactions. And the rest is the problem of the database server. If you, for example, you are using non-locking reads, in InnoDB reads are non-locking by default, then the transactional logs do not matter. Only if the table is being dropped or something like that, then you will have a conflict with non-locking reads. But the row logs do not matter for read uncommitted or read committed or repeatable read isolation levels. But inside the database we have some concurrency bottlenecks that you may hit, such as if multiple queries are trying to access the same page while the page is being written by some transaction, then the read access to that page would be momentarily blocked. Also, if you have lots of writes, you can have a bottleneck on the redo log buffer or the redo log file. And if your workload is much bigger than the buffer pool, then it could happen that the server is spending a lot of time in evicting pages and writing back changes from the buffer pool before it can evict those pages and get new pages into the buffer pool. To understand how a system works, it's good to follow the open system interconnection model that is used for protocol design or description. If we look at the internet, at the lowest layer we have a physical layer, a transmission medium such as a serial line or Ethernet or Wi-Fi. Those are asynchronous packet-oriented communication media. Anybody who is connected to that network can choose to send something, a packet, at any point of time, and there must be some collision detection, collision avoidance and such things. And as we go up the layers, the bottom layer, the service that is provided by the lower layers is refined by each upper layer. At the top we have the TCP/IP, the transport layer, which takes care of retransmitting data and flow control, so that this packet-oriented communication becomes stream-oriented or connection-oriented. Similarly, in databases at the low level we have some storage hardware such as a rotating hard disk or flash memory, also called SSD, or a special kind of flash memory like a persistent memory, which can be written directly from the processor, 1 byte at a time. And on top of the storage layer, the operating system implements a file system layer and a file system cache. Examples would include the ext4 file system in Linux or the NTFS in Microsoft Windows. On top of the operating system and file system, we have the database server process running. And the lowest layer of the database server is the mini transaction layer and the buffer pool, which is a kind of a page cache on top of the files that it is accessing. This mini transaction layer is providing atomic changes to multiple files with crash recovery, so it's atomic and durable. If something is has been durably written by the mini transaction, then it must be recovered. The system must be recovered at least up to that logical time point if it gets killed and restarted. And on top of the mini transaction layer, we have a user transaction layer which provides things like transactional isolation and multi-versioning concurrency control. For InnoDB, those would be implemented in terms of undo log pages, but other storage engines might use a different approach. For example, RocksDB is not using undo log pages, but it is buffering all changes before transaction commit, and only at commit time it will write the changes to some log. So we have some dependencies and constraints for implementing the atomicity and durability. At the mini transaction layer, we have a concept called log sequence number. It is the logical time of the system. It's basically the number of bytes that have been written to the write-ahead log file. And it's totally ordering those mini transactions that have modified some persistent pages. If a mini transaction is committed and its log has been written to the redo log file up to some LSN, then crash recovery must recover the database to at least that LSN. All the changes must be visible after restart. On top of the mini transactions, we have user transactions, and InnoDB implements those in terms of undo log pages and some system fields in the index pages, transaction identifiers and undo log pointers. And the important thing to notice here is when a user transaction commit becomes durable. Well, InnoDB is writing the undo log before it is making any changes, before the changes become durable. So anything that is done in the transaction will already be done to all the index pages and to the undo log pages. And at commit, only thing that happens is that we will mark the transaction committed in the undo log page. And when that mini transaction for marking the undo log page committed, when that mini transaction is durably written to the redo log, the user transaction is durable. Basic idea is that we follow a write-ahead logging protocol. We must not write anything to persistent data pages before the corresponding change has been durably written to the redo log. This guarantees that the redo log is never behind the state of the data pages, and recovery can be done based on reading the pages that are mentioned in the redo log and checking if those pages are older or newer than our redo log records. There is of course no point to apply redo log records which are older than the page. And to speed up crash recovery, we have this thing called a log checkpoint, which will write all change, which will ensure that all change pages older than a checkpoint LSN have been durably written to the data pages, and then the log checkpoint can logically discard the beginning of the redo log, marking that recovery will start from the new log checkpoint LSN. On shutdown, we do a log checkpoint and the log would be logically empty. after that. So after a normal shutdown, the server startup will recover with an empty log. The next slide describes the flow of a mini transaction. It's the most challenging slide in my presentation, so I must apologize for the level of detail, but I feel that this is necessary to understand the scalability bottlenecks of the InnoDB storage engine. At the left side we have a mini transaction object which is combining a memo which keeps track on read-write logs, also called latches, that the mini transaction is holding. And in the blue entity we have a log of changes to pages. If the mini transaction has before a mini transaction can change an index page or any page in the buffer pool, it must acquire exclusive latch on that page. So no other user of the database, no other thread can access that page. Not even page flushing or checkpoints can access that page. So once we have the exclusive latch on the page, we are allowed to make modifications, and all modifications will be written to the local log buffer of the mini transaction. In the middle we have a number of buffer pool pages associated with the mini transaction. Those ones in blue color, the three blue boxes, represent pages that have been modified. There is also one white page which is a page that has not been modified. The mini transaction could release that page earlier so that it can be accessed by other threads in the database. Also, the memo is pointing to an index latch. In this diagram at the top we have an index latch. It is protecting access to the non-leaf level of the index tree. So if we are starting from the root of the index tree and we are diving towards the interesting leaf page where our key or data is, at the start we must hold the index tree latch to prevent any other thread from changing the upper level pages before we have reached the leaf level. And once we have reached the leaf level, we can release that index latch. Other thing in this diagram is the table space latch. If the mini transaction is allocating or freeing pages, then the allocation bitmap pages, to prevent deadlocks for accessing them, we are additionally acquiring the table space latch. So once we are done with the changes in our mini transaction, we can only commit that mini transaction. The only other way to get rid of a mini transaction is to kill the server. Every mini transaction has to commit. So at commit, the mini transaction will copy the local log of changes to a global log buffer. For that it will acquire a mutex on the log buffer so that it can copy to that buffer and get back the logical position, the end of that buffer, the LSN. And then it can release the log buffer mutex. And after that we have the LSN. We will write the LSN to the fill page LSN header field of each modified page. And if we find a modified page which had not been modified, which was not in modified state yet, we will notice that the oldest modification field in the block descriptor is 0. In that case we will set the oldest modification field to our end LSN and we will move that block to the flush list. Okay, and this after all these steps we are finally allowed to release all the latches that the mini transaction was holding. We will release the latches and we will let other threads to access these pages that we had exclusively latched. And after some time, some thread will write that global log buffer to the redo log file in MariaDB Server 10.5 there is only one redo log file, IB log file 0. In previous releases you could have multiple redo log files which were logically one file. So basically those multiple files were treated as if they were concatenated together. So we will write the log buffer to the redo log file, and if this was a mini transaction that did a user transaction commit, then that user transaction thread would actually wait for this redo log write to happen. And after this log write, we are allowed to write modified pages to data files. So if the LSN in the page header is not newer than what has already been written to the redo log file, we are allowed to write it to the data file, and we will remove the block from the flush list and reset the oldest modification field back to 0, and then the block is in clean state, and it can be evicted if some thread needs to read another page and the buffer pool is full. Then we have this log checkpoint. The log checkpoint which will ensure that we will not overrun our circular redo log file, and it will also ensure that the recovery will be fast. The log checkpoint will first go through the flush list. If there are any pages in the flush list, it will find the minimum oldest modification in the flush list. This will be chosen as the log checkpoint LSN. We know that everything older than the oldest modification has already been written to the data files. If the flush list is empty, then we know that everything up to the current LSN of the system, the latest LSN, has been written to the data files, and we can choose that as the checkpoint LSN. So the checkpoint will copy the checkpoint will write the checkpoint LSN to a log file header, and that will mark the checkpoint as completed, and recovery would then start from that latest checkpoint LSN instead of starting from the previous checkpoint LSN. And now we are free to reuse the space of the circular redo log file for further log. So you could have like 1 gigabyte log file, and you could have written several terabytes of redo log. But because the checkpoint is never bigger than maybe half a gigabyte, then there is no correctness problem. We can always recover from that log. One more thing related to page writes is that when we are writing a page from the flush list to the data file and the server is killed, it could happen that we get a corrupted page. We could have written the first part of the page, but the tail of the page was still corresponding to the old state. So the page check somewhat detect corruption. What can we do in recovery? We can only apply log to pages that are in some consistent state, corresponding to some LSN. The solution that InnoDB uses for that is a double write buffer. We will first write the page to the designated area in the system table space, and once we have completed that write, we will write the page to the data file, and this ensures that if the server is killed in the middle of a page write, we will be able to recover the page from the double write buffer. A kill during a redo log write is not a problem, because the recovery will scan the redo log sequentially, and it will stop when it detects end of the log, some inconsistency, something that indicates that the last mini transaction was not properly terminated. So recovery would discard the last incomplete mini transaction. It must be atomic and durable, you remember, and it will recover everything up to the start of that last incomplete mini transaction. The next section of my talk is covering the actual improvements that we have done to MariaDB Server 10.5 release to improve, mostly to improve write speed and recovery speed, but also we are slightly improving read performance. So the main thing in the 10.5 release, most visible thing, is that we changed the redo log record format. We replaced the old physiological redo log format with a mainly physical redo log format, and we introduced some new special redo log records that allow us to avoid some page writes and reads. If you are freeing pages, we will now write a special log record for that. For example, a drop index operation or a large rollback, which would often insert, that would free lots of pages. In those cases, we would write this special record, and when we come to the page flushing, we will know that this page was actually freed and we don't need to write anything back. So we can actually evict the page from the flush list without writing it to the data file at all. Or if we have this feature called scrubbing enabled, in that case we would overwrite that page with zeros. But normally we would avoid I/O. Similarly, if a page is newly reinitialized by a redo log operation, for example, a page was split and a new page was created and initialized, then for the first write of that page we would not use the double write buffer. The reason is that we are able to recover the page based on the redo log records only. So recovery will not read that page. It will just read the redo log records, and there is no use of the double write buffer because recovery will not need to read the page. And other things that we did without file format changes are an improved group commit, removing some mutex contention on the operation that is ensuring that everything to a particular LSN has been written to the redo log. Also, we introduced a compilation option for persistent memory storage, which allows us to write to the redo log without invoking any system calls. And this new redo log format is easy to pass because it's explicitly encoding the length of each record. This is greatly simplifying recovery and also hot backup with the Maria backup tool. And it also allows us to improve the memory management. Yes, I already covered this. We have fewer writes and reads of data pages. Recovery will not read any pages that were initialized based on the redo log record, and page flushing can skip the double write buffer for those pages. And when we are freeing a page, we will not have to write anything to the data file. We can just discard the page from the buffer pool unless scrubbing was enabled, or unless you were using page compressed tables and you would want to have those holes in your data file in place of the freed pages. And this special record might allow us to avoid writing any short-lived pages, such as when you have temporary tables. It could be that if the temporary table exists for a short time only, then we might avoid all page writes for that table altogether. Faster log writing is mostly thanks to my colleague Vlad Weintraub, who introduced a new type of log for more efficient synchronization of concurrent threads that are attempting to write to the redo log. And when Vlad was benchmarking his work, he noticed that the redo log volume makes a big difference to performance. If we write only a little bit more redo log, the performance with higher thread counts would easily collapse. So this is the reason why we didn't go for purely physical logging for the page operations. For example, if you are inserting a record to an index page with the physical logging, you would have to write log records for updating several fields in the page header, such as the number of records and the next free byte on the page and such things, and also pointers from the previous record to the newly inserted record, and also page directory items. All those are now covered by a special insert record, which basically contains a little bit information that allows us to determine the insert position based on the page contents and then the record payload with as little data logged as possible. And this is actually reducing the redo log volume a little bit compared to earlier versions. And I mentioned this persistent memory interface. It was done by my colleagues Sergei Voitovich and Yevgeny Kosov. They implemented this libpmem interface. Basically, we are writing to a memory mapped file. The redo log is memory mapped, and to make the write persistent, we are executing a cache line flush instruction from the CPU. There is no system call involved for the redo log write. Recovery was mostly improved by the more easy to parse redo log record format. We have the explicitly encoded lengths, so first when we are buffering the records before we are reading any pages, we can just quickly buffer them. We know which pages they are for, but we don't need to parse the payload of those records. We just skip to the next record based on the length that we pass from the start. And we also have a simpler memory management. In the old format, it could happen that some logical redo log record could be bigger than the page size. For example, if you are using 16 kilobyte page size, you could have an individual redo log record that is longer than 16 kilobytes. So we would need some special code to manage those very long redo log records. In the new format, that can never happen, so we can directly buffer those records in buffer pool pages, which is much simpler. And these logical records that we introduced for page operations, they include much better validation of the page contents than we used to have. Previously, in the old recovery code, you could get a crash during crash recovery, but with the new code, you should get a clear error message that the page was corrupted and the log record was not applied to it. So you will know that there is some problem with this particular table space. The next section of my talk covers some code cleanup that might improve the performance of InnoDB in MariaDB Server 10.5. All these changes were done without changing any file formats. There used to be a single master thread in InnoDB that did various tasks, such as change buffer merge or purge of transaction history or checkpointing. Over the time, more and more dedicated threads were added, and the problem with that is that those threads are mostly idle most of the time. They are waking up every now and then checking if there is something to do, and this is unnecessarily consuming some memory and also creating unnecessary work for the thread scheduler in the operating system, especially if you have a system with few processor cores. To help that, in MariaDB 10.5, my colleague Vlad Weintraub introduced a thread pool that is used for some InnoDB background tasks. For example, the purge of transaction history is now run in tasks of the thread pool instead of being dedicated threads. And in the MariaDB 10.5 Enterprise Server, you can dynamically change the number of encryption tasks, purge tasks without restarting the server, because it's easy to add more tasks to the task queue, and the thread pool would dynamically create new threads if there are many tasks waiting, or it would shut down those threads when they are becoming idle. To improve the performance of purge, we did also some other changes. Mostly it was my colleague Thiru who did those changes. One of the optimizations was that the work is now being sorted by table identifier. If there are multiple undo log records for the same table, then those would be processed in a batch in one purge task. So we would look up the table by the table ID and acquire metadata log on that table, and then process a number of undo log records for that table, and finally release the metadata log and proceed to the next record. If the table by the table ID doesn't exist, we used to be so that for each record we would look up the table in the dictionary cache. If it's not in the dictionary cache, we would attempt to load the table from the InnoDB dictionary table. And of course, if the table was dropped, it is not going to reappear there. So now we are optimizing away futile lookups of already dropped tables. We will only look up once and then skip all the records for that table ID until we find some other table ID, and then we might get that old table ID back again. But anyway, we have much fewer lookups for non-existing tables. One thing that we could improve in the future is to scale this background activity based on the foreground workload. For example, if the server is extremely busy, we might want to suspend the purge activity for a while and let the busy activity continue in the foreground. This is of course not without some trade-offs, because if there is lots of unpurged history in the database, then the things like multi-versioning, reads, constructing old versions of records, or checking if a secondary index exists in the read view, they could become more expensive. So there should be some good trade-off to control the purge lag. One thing that we cleaned up in the 10.5.5 release was deprecation and ignoring of parameters related to InnoDB thread throttling. Back in the old times, like MySQL 5.1, when we only had this master thread doing everything, you could easily have and we not only that single master thread, we would also have a single kernel mutex, which would cover different things such as the transaction bookkeeping and the log bookkeeping. We would also have a single buffer pool mutex, which would cover various operations on the buffer pool. So those would be very obvious bottlenecks that would prevent the system from scaling if you got more than, say, 4 or 8 concurrent connections. And to work around that bottleneck, there were these parameters like InnoDB thread concurrency, InnoDB commit concurrency, and I think it was something like InnoDB replication sleep delay or something like that. And it turns out that currently, thanks to scalability improvements that have been done over time, both in MySQL but also in MariaDB, we actually do scale to a rather big number of concurrent connections. There is no obvious bottleneck if you run an in-memory workload with 1000 concurrent connections or even several thousand on a system that has like 50 CPU cores. So that is it's kind of obvious that we don't need this concurrency throttling anymore, and it's actually harmful when users accidentally have some old config file that is limiting the concurrency for no good reason. So we are deprecating and ignoring these parameters, and they will be removed in the next 10.6 release. and hopefully the removal of some bookkeeping related to these parameters will also slightly improve the performance. I mentioned this change buffer. It is one thing that was done in a background task. Well, in the 10.5 release we removed the background merge of the InnoDB change buffer. The idea of the change buffer is to optimize performance on hard disk when a secondary index leaf page is not in the buffer pool and we want to insert or delete mark or purge something in that page. We would avoid reading that page into the buffer pool, and we would instead write a record to a special change buffer tree. And later on, when the page is read to the buffer pool for whatever reason, the buffer changes would be merged. And there used to be a background task for merging the change buffer to kind of keep the database in a clean state. But it turns out that this background merge was slightly harmful for performance, and it's also harmful for usage, because if there is some corruption, you know that if InnoDB encounters some corruption, it's not handling that very well. So it would basically just crash the server when doing a change buffer merge at any random point of time. You would have no clue what table it is, what index it is, what is causing that. But now with MariaDB Server 10.5, it's more predictable, because typically the change buffer merge will occur when the current query in the SQL statement is accessing that secondary index. So it's much more obvious if you get that crash. Well, yes, we can still get the crash. That's something that we should fix in a future release to improve the error handling. But anyway, you get the crash and you have a better idea of what is causing that crash, and you can work around it by executing drop index. The server will not crash automatically when you restart it, because there is no background merge for the change buffer. So this is quite a nice improvement in my opinion. And future work, we should improve the change buffer format, make it more logical, remove some limitations. We should actually allow page merges to happen. Like if you are deleting the last record from a page, we should allow change buffering for that. Currently we don't, because a change buffer merge must only operate on one single page at a time. We also cleaned up something in the data dictionary. I mentioned that the purge threads are now using metadata logs. We used to use an InnoDB-wide global read-write log called the dict operation log, or in 10.5 it's called the dict system latch, to prevent the concurrent drop or any other DDL operation while we are processing the undo log records in the purge. But now we have split that. We are acquiring the metadata log instead, so there is more concurrency. And I hope that in some future release we can get rid of the dict operation log altogether, and also get rid of the InnoDB table logs and use the MDL for both. In the buffer pool we did some performance improvement work. I mentioned that the buffer pool mutex used to be a bottleneck. There has been some work over the time. A buffer pool hash table that maps page numbers to buffer pool blocks. For that a partitioned read-write log was used, and maybe even before that the entire buffer pool was partitioned to, in a visual thinking that other threads will use another buffer pool instance while your current thread is accessing this one. But I think that this multiple buffer pool is complicating other things, such as page flushing, and it also makes it difficult to make use of atomic memory access to get rid of mutexes. So in MariaDB Server 10.5 we reverted back to a single buffer pool, and we did some changes to remove some mutex operations. We even were able to remove the buffer block mutex, which was introduced to reduce workload on the buffer pool mutex. Thanks to using atomic memory operations, we don't need the buffer block mutex in those cases where it was previously required. And we also introduced a CPU cache friendly page hash for mapping the page numbers to buffer pool blocks. The latch for protecting the hash array is now part of the hash array on the same cache line. We were not able to do all the performance improvements that were planned for the 10.5 release, so there is something that is going to happen in further releases as well. I will shortly cover those ideas. One idea to improve the writing speed is asynchronous commit. If you have a client that is sending a stream of SQL statements like begin, do this, do that, commit, begin, do the next thing, commit, and so on. Currently, the server would wait for the redo log write to happen for the first commit, and only after that it would start parsing the next statement from the client connection stream. My colleague Vlad has this idea that when we write the redo log for a particular user transaction commit, we would send the OK packet to that connection on write completion, and in that way we would be able to process subsequent statements from that client connection without blocking on the server side. Of course, the client can still wait for the OK packet for its commit if it thinks that it's necessary. Other idea which doesn't require file format changes is that we could recover pages from the redo log while allowing connections from users. Currently, InnoDB recovery, the redo log recovery will be completed before any connections are accepted. Undo log recovery, meaning any recovered incomplete transactions, they will be rolled back in a dedicated thread, but the redo log processing is currently completed before any connections are accepted. And this is something that we could improve. When we improve this, we would also be able to start up, or should be able to start up a database on a read-only file system. You could have a copy of something that might have been killed, and we would do the recovery in memory. We would not write anything back to files, and you would be able to see what is inside those files, or you would be able to dump the data without writing anything on disk. To conclude my presentation, I think that the MariaDB Server 10.5 release is making much better use of the available hardware resources, and it should be scaling from small systems to big ones. We removed lots of confusing or useless or outright harmful parameters, and we made some parameters dynamic. And we improved performance and scalability for various workloads. But as always, when one is fixing some performance problem, it can happen that some other bottleneck is emerging, and it could make some things worse in some scenarios. But for normal workloads that fit in the buffer pool, I think performance is okay. And I find that performance must never come at the cost of reliability or compatibility. So if anything that is unsafe, we shouldn't do such optimizations. It must always be safe, and recovery must work. We have a rigid testing process based on random query generation and using repeatable traces for analyzing race conditions. The RR tool from the Mozilla Foundation is very useful. So I think reliability is covered, and compatibility, we have upgrade testing from old versions, and we try to keep data formats compatible so that you are able to downgrade to an older version in the same series. For example, if you upgrade to, let's say you upgrade to 10.5.8 version in some point of future and there is some bug that you are hitting but we didn't find in our quality control, you should be able to downgrade to the previous working version of the 10.5 series and you will be in business. Some other databases might change the format between minor versions and then it's only one way, and if you hit a bug in that new version then you should have had a logical backup or something that allows you to go to the old version. And we are working on these performance things, so watch out for more improvements in future release. Thank you for your attention, and now it's time for your questions. Thank you.
Marko Mäkelä, thank you. Great presentation on InnoDB. You're calling in from Helsinki, Finland, are you?
Yes, I'm calling from my home cathedral that you saw on the video. I have a long-term transactional marriage with this code base and I enjoy it.
So I think your cathedral reference was a pun related to Eric Raymond's book Cathedral and Bazaar. So you seem to be a cathedral person then, are you?
Yes, but I prefer to work in an open development way like the Bazaar. We are open for contributions from the outside, and just today or yesterday, depending on how you count the time zones, I had interesting discussions with somebody from Scaleflux who gave this presentation about smart storage, or I don't remember which term he was using.
Good point. Let's return to that one. But I have a couple of InnoDB questions first. But then I'm all ears and eager to listen to your interactions at this virtual event. So one thing you did not talk about in your presentation was online alter table and instant alter table. Those are things that people frequently talk about when it's InnoDB discussion time. And I know that they are not the freshest ones. Some of them are older and some of them are younger. But what really is the difference between online alter table and instant alter table or DDL operations, and when did they come into MariaDB?
Actually, I gave a talk about this in the beginning of the year. We had this FOSDEM conference in Brussels, and you can view the online recording. But basically, in the beginning of MySQL, there was no special alter table interface. There was only create table, drop table, and rename table. And everything else was emulated using this operation. So when you did alter table, the SQL layer would create a new table with temporary name, and then it would execute like insert select, copying all rows one by one from the old table to the new one. And then it would rename the original table to another temporary name, and then rename the new table to the original name and drop the original table. And that was, of course, very slow, especially because InnoDB was writing undo log record for each row that it's inserting. And in this case, if you wanted to abort the operation, of course, you would only have to drop this intermediate table. But in fact, InnoDB was writing undo log for each row so that it can roll back. And sometimes it would occur that the impatient DBA would kill the server, think that, oh, this alter table is taking forever, I will kill it, and then restart. And what would happen? Well, of course, if you had 1 million rows in your table and there was this InnoDB insert buffer, which would speed up the operation when you insert into secondary indexes, okay, nice. But when you restart the server, it will do this crash recovery, it will roll forward the redo log, and then it will roll back the undo log. And those 1 million rows, when it's doing rollback, the change buffer or the insert buffer will not be used. So it will have to read all those secondary indexes to the buffer pool and remove those rows that were inserted and so on. This was actually something that was finally fixed in MariaDB 10 to 14 or something like that release. We removed this unnecessary undo logging. So now if you kill such an old-fashioned outer table or kill the server, you will not be punished so much.
There will not be that lose-lose situation any longer, okay?
Yeah, but anyway, that was the old-fashioned outer table. And then for the MySQL 5.1 release, we had a separate InnoDB plugin, which was developed by the InnoBase company as it was owned by Oracle. We were very separate, like behind the Iron Curtain. We were like the Soviet Union and MySQL was the freedom, but finally this we got to the same side of the fence. I mean, MySQL and InnoDB were both part of Oracle and things were starting to move better. But anyway, in 5.1 we had this InnoDB plugin which supported fast index creation. That code was made part of the 5.5 release in the default InnoDB implementation. That would basically allow fast creation of secondary indexes or adding a primary key to a table, but it was not online outer table. It would do some merge sorting, pre-sorting the index records. It would be faster in that way, and it would skip the undo logging, but it would not allow concurrent modification. Also, at some point, I think it was MySQL 5.6 where we started to really improve the outer table. We got instant operations, like if you rename a column, we would no longer do this stupid copying the table thing. We would just update the metadata. Or if you extend the varchar column, you would also in some cases be able to do that instantly. But that was in MySQL 5.1 and MariaDB 10.2. 5.6 release was the baseline for MariaDB 10.0. So gradually we got these instant operations for simple things like renaming columns and extending varchar columns. And in the 10.4 release of MariaDB, we extended those further. Like if you change the collation of a variable length column from 3-byte Unicode UTF-8 to 4-byte, it could be done instantly. And in between, we got the instant add column and instant drop column. Instant add was done in the 10.3 release. The idea actually started in one unconference meeting in New York. And then in 10.4 we got the instant drop column and changing the ordering of columns. And yes, one more thing that you asked, online alter, allowing concurrent modification. That was something that I implemented in the MySQL 5.6 release. I was kind of married with my QA guy, Matthias Leich, and I'm happy to be married with him again because he joined MariaDB a couple of years ago. So we are again doing this kind of ping pong. I'm writing code and he's running the random query generator and giving me core dumps, or nowadays these RR replay traces that I can easily check the exact sequence of events and debug even challenging race conditions.
Marko Mäkelä, the man of many analogies and transactional relationships and marriages. So great. So now moving to 10.5, MariaDB 10.5, what InnoDB feature are you most proud of in this release?
Well, it's I don't know if you can call it a feature, but the write performance. We have a faster writes to the redo log, a more efficient redo log format, which also enables fast recovery. So everything related to that. But unfortunately, there was some, or performance is always like a challenge. While correctness is fairly easy to guarantee with tests, performance is harder because there are so many parameters that affect it, and tests take longer time.
Yes, so there was some regression problem now related to a performance regression issue related to InnoDB lately. So what was that all about, and what is your take on it?
So the idea was, or the background is that that in MySQL 5.5 there was this buffer pool mutex contention, which was kind of worked around by splitting the buffer pool into multiple instances. You would basically compute a hash value of the page number and then choose the buffer pool instance based on that, and then have in each buffer pool instance you would have only those pages would belong to that instance, and it would complicate things like page flushing and many other operations, but you would have less contention on the buffer pool mutex. So I thought that there have been so many scalability fixes already in the code base that maybe we can move to a single buffer pool instance again. And it was actually working nicely in most benchmarks. There was one case that we deemed as a corner case, that when your buffer pool is full with dirty pages and you need to write out some pages to get space for new pages. In that case, we actually did see that there was a regression when compared to using 4 buffer pool instances. And to counter that, I implemented or made some changes, reduced the contention on the buffer pool mutex by making use of atomic memory operations and so on. Okay, but as always, when you do some performance work, it often happens that some the bottlenecks will move somewhere else, and it might even be worse. So I had to implement a new lock-free hash table for mapping buffer page numbers to block pointers. That I fixed, and we got a bit better in 10.5.5, but still we had one more regression, which is a very extreme case when you have lots of dirty pages in the buffer pool, the TPCC benchmark. And I'm happy to tell that last week I made a breakthrough. I got that benchmark mostly to, I mostly removed the regression, and this week I have been refining it, and today's numbers look like we are close to removing the regression altogether.
Cool. That's great. Hey, let's get back to what you were saying in the beginning. You wanted to say something about an interesting interaction you had, I believe, with Tong Zhang, and it was discussing SSDs and how to optimize MariaDB on a hardware level redo log, or what was it about? So can you tell how did that discussion start, and what is it all about?
Yeah, so I didn't watch his talk live, but I watched the recording, which is a nice feature of this conference format. So basically, the idea is that that we can have a smart storage that does some compression on its own, and by changing the data format of the redo log blocks, we can assist that kind of compression, so that if we need to write an incomplete redo log block, we can hint to the smart hard drive that, okay, we are only using this part of this 4K block. We must use the 4K block because the Linux kernel file system cache works in that way. But we can actually tell that we only need this 100 bytes of payload there. So the flash drive can do its own thing. It can buffer it in some capacitor-backed RAM and then write to a block later or something like that.
Hey, I'm happy to hear that such an interesting discussion happened as a result of this conference and of the conference format, as you said. So thanks a lot for a great presentation and an interesting chat with you, Marko Mäkelä. Thank you.
Thank you. Bye.
Now for a hardware-related presentation by Krunal Bauskar, MariaDB on ARM.
Hello, welcome all. My name is Krunal Bauskar and I have been driving this MySQL on ARM initiative. As part of this initiative, today we are going to talk about MariaDB on ARM. I'm sure you would find a lot more interesting thing about MariaDB on ARM, and it will help you make a choice whether you should run MariaDB on ARM. So let's get started now. That's quick intro about me. I have been working in MySQL space for quite some time now. I have also worked with Percona as a PXE product lead, managing all aspects of the PXE, including performance. Before that, I worked with MySQL Oracle team as InnoDB developer and worked on some of the features during 5.7 timeframe. Also in past, I've worked on big data problems at Yahoo Labs, or I've also worked on a project for a startup, which is now part of Teradata. And we made the world's fastest storage engine for MySQL and lot more such projects. Currently, I'm working at Huawei as part of open source DB group and responsible for all flavors of MySQL ecosystem, which include MySQL, MariaDB, and Percona. So as I said, I've been driving the MySQL on ARM initiative. So with that quick intro, let's now get started with our talk. So that's our agenda for today. So first we will see ARM ecosystem. We will try to understand why ARM ecosystem is gaining traction and why it is important. Then we will talk about MariaDB and ARM. And then we will see how MariaDB performs on ARM with some performance number. Towards end, we will talk about the state of ecosystem. So with that agenda set, let's get started. So first thing is ARM ecosystem. So I'm sure you have heard of ARM processors. But the context in which you have heard, probably most of us have heard, is mobile or network equipment. Most of our mobiles are powered by ARM processors because ARM processors consume less power, and so they can use the battery better. Now, if you stretch your thinking further, you would observe that ARM processors are also widely used in housing appliances. A lot of housing appliances use ARM processors. If you stretch it further, you would discover that ARM processors are also used in automobiles, especially self-driving cars, and with increasing automobile using electronic circuitries, defense space where the usage or usage of power is important. All these kind of application ARM processors have been gaining traction. Something which is new is HPC. HPC stands for high performance computing. Most of our products like application server, databases, big data falls under HPC. So thanks to the performance per watt, as I said, ARM processors are better at are optimal at consuming power, thereby reducing the cost of ownership. And they are getting more and more powerful with additional computing power that makes them a suitable choice for even use in HPC. Now, something which has changed in past couple of years is few years back, if you wanted to boot a very strong ARM instance for running your HPC application, there was nothing available. But in past couple of years, a lot of cloud providers have started offering ARM instances. For example, Huawei Cloud offer a ARM instance using its high silicon Kunpeng 920 processor. AWS offer ARM instance using Amazon Graviton 2. There's another startup called Ampere, which is trying to develop ARM-based, cloud-ready ARM-based processors under Ultra series. So with options available, developer can now easily port their application to ARM, and user can eventually start directly running their application on cloud using ARM instance. But only having hardware doesn't help. So the software also has to be evolved, and that's exactly what we call as ecosystem. Fortunately, in past few years, all major OS providers has been able to provide OS support or OS releases for ARM. Then beyond that, if you look at projects, right, the applications, so most of the applications now are either supported on ARM or work in progress. For example, big data, the Hadoop, which was the base for big data application, is already now supported officially on ARM. Application servers, load balancers, databases are most of them are either work in progress or supported on ARM. Now, ARM Cloud Instance, so the reason why ARM is gaining so much of traction is in ARM is supposed to generate a direct saving of 30% by keeping performance on par. So that has been the motivation or USP why ARM is gaining so much popularity. So strong presence of ARM on data generating device is also going to fuel why ARM should be also used for backend server. So your complete end-to-end ecosystem chain is could be booted on ARM. Now it is estimated that by 2030, most of the HPC application will be running on ARM instances. Let's see, it could be earlier based on how the things evolve. Okay, so that with that, a short intro about ARM ecosystem. Now let's talk about MariaDB and ARM. So fortunately, MariaDB is already part of ARM. MariaDB has been releasing packages for ARM on distros like CentOS and Ubuntu, while there is a work in progress going on to add support for more distros in near future. So we are hoping that almost all the distros, major distros, will be supported. MariaDB not only support MariaDB server on ARM, they have spent good amount of time and efforts to optimize it on ARM. We'll see what some of these optimizations, but as I say, optimization is a never-ending process, so the effort will still continue. In fact, MariaDB was first to add support for ARM. And as I say, MariaDB has a full support or GA, which means all your bugs, whether it's functional bugs, correctness bug or performance bug, will get addressed with the same priority like x86. So that makes MariaDB an ideal choice as a database or open source database to be run on ARM. Now, when you add any additional architecture, you need to face some basic challenges, and ARM is no exceptions. So let's understand what challenges are involved when you port any HPC application to ARM. So ARM is a weak memory order. We all know it's a weak memory order. So to get optimal performance, proper memory ordering has to be used. x86 is a strong memory ordering. So if you are just reporting the code will of course work, but will not get optimal performance. Thankfully, C++11 added a support in its standard for memory ordering, and MariaDB being C++11 compliant was able to harvest this memory ordering support and make optimal use of memory order to get maximum performance on ARM2. Tuning code for ARM. Now ARM is a different architecture altogether. So low-level loops or basically code like spin loop, right, needs to be readjusted. I would say readjusted and retuned for ARM processors, because the instructions for pause are different. How much time you want to spin would be different based on the frequencies and all. So accordingly, you have to make sure that code is retuned for ARM processors. So ARM is all about more cores, maybe less powerful, and more. That means more NUMA nodes. So any software that needs to have given with more cores should able to use them efficiently. What I call it to be a NUMA compliant or basically a NUMA optimized software. MariaDB was already NUMA compliant or optimized, since x86 also has multiple NUMA nodes. But additional cores, how to make use of additional core, MariaDB actually have tuned or have solved a lot of scalability issues while working on ARM. And I could say that MariaDB is now completely or I would pretty well optimized for more cores that ARM processor throws at it to make maximum or optimal use of these processors. Beyond that, ARM do provide some acceleration instructions in form of neon SIMD LSE. So atomic instructions, special atomic instructions, or optimizations of it. So all these, even with vectorizations and all these things are also provided by x86. But since the code or these are low-level hardware instructions, you may have to write a parallel code along x86 for ARM purpose too. So making sure that you tune all such code snippets and enable them for ARM from optimization perspective is also important. ARM has a different cache line requirement. So making sure the cache lines is adjusted, alignments, memory alignment hints could be needed. There could be pipeline differences, a code which could be hotspot, which is not hotspot on x86 could be turned out to be on hotspot on ARM. So making sure you understand discover such code, retune them is needed. And switching to use hardware optimized support. So there are few functions which hardware can also do. For example, very good example of this is checksum. So when x86 also provided such functionality where it could compute some of the things directly at hardware level and they're faster. And the same support is also offered by ARM. So making sure that you discover such code and get it ported and use the relevant functions from ARM hardware architecture is important for making software performance optimal. So these are few challenges that any HPC software will have to face, and of course MariaDB has already faced. So if we look at the complete solution, all the issues, then you could look at, see, this is a partial picture that we are trying to provide. MariaDB have addressed almost on all front some optimization has been done, whether it's memory ordering. So memory ordering has been taken care of. We just talked about one of such challenge. NUMA scalability, even on NUMA scalability like spin lock optimization, timer counter optimization, cache line sharing, all such more optimizations has been taken care of. Whether it's use of Neon, even that has been taken care of, moving to atomics so that it is able to scale correctly. Use of checksum, we just talked about the checksum example, making sure the hardware checksums are used. So when MariaDB made optimized MariaDB server for ARM, they made sure that the optimization is not only done in one direction, but all aspect of optimization for HPC softwares are taken care of. And the result of this is the complete upliftment on all scenarios, or I would say all use cases. You could see that MariaDB server on ARM performs better. So all these good optimizations, let's understand how they are going to help. Okay, so only one way to find out is by benchmarking. So we will try to look at some of the benchmarking numbers with this. Before we get into the real benchmarking, let me introduce you the cost performance model. I'm sure you might have heard something similar to this in past, but let's talk about it, what I meant by cost performance model. If you boot a ARM instance and if you boot an x86 instance, roughly with the same size of computing power and memory, you would see that almost on all cloud provider, ARM instance provide a decent saving, anywhere ranging from 20 to 50%. So that is expected because that's the USP of ARM resources. So of course, the idea now would be that can we leverage this cost saving and still get improved performance. So if I can run the same software on x86 with the same configurations and on ARM, and if I could still get on par performance, I could say that I have achieved a 40% saving. Okay, so this is the existing model, but there are challenges, right? The challenges are CPU frequencies when you compare two instances of ARM. Like here, if you compare on Huawei Cloud, the Kunpeng ARM instance is 2.6 gigahertz, while the respective instance of x86 is have a base frequency of 3.0 gigahertz with a turbo frequency of 3.4 gigahertz. So these frequency differences make the comparison challenging or basically not on par. Beyond that, Intel has turbo mode, which means on lower scalability, Intel is always going to score because it is going to use its turbo mode. Now, CPU generation differences are also there. Now, Intel itself being in race for quite some time now, it has its Broadwell, it has Skylake, it has Cascade Lake, and more such things. So there are CPU generations differences. Now, x86 cores have physical core. There's a concept of physical core versus HT core, what we call as hyper-threaded core. And what cloud provider provide you is vCPU, right? So there are these differences. There could be NUMA arrangement differences. NUMA make a difference, and with increasing cores, more NUMA nodes will be there. There could be memory differences. Scheduler, what I've heard is with Linux kernel 5.x, there is improved support for multi-NUMA architecture. So that's another thing to consider. So with all these things in place, it's important that we can't directly compare, or it would not be an apple-to-apple comparison just for purpose of cost saving. So we developed a different model, or we just proposed a different way of looking at it. What if we could say we could keep the cost constant, and let's analyze if we can get more throughput on ARM, thereby turning into more TPS per USD. So if I put it more formally, if I have X USD to be spent, what I'm going to do is I could get M ARM resources and N x86 resources, of course more ARM resources. Can we get increased performance from these M ARM resource? So for cost constant with ARM resource, I'm getting more performance, thereby it is increasing my TPS per USD. I put it more into form of definition. Given the on-par cost of both the resources, can we exploit ARM variant to its fullest benefit and get better performance when compared to x86? I think that's fair enough to consider. So let's understand whether we can apply this model and then analyze how ARM performs with respect to x86 using MariaDB as an example. So this is just a quick example of if you try to boot a VM on Huawei Cloud, almost of the same cost, x86 and ARM, you would discover that, and the memory is also same. For the keeping all other configurations same, it typically looks to be that the computing power is almost double. Okay, so there are 2x more core. I shouldn't say computing power because there is a frequency differences, but let's assume that you can get almost double the cores or 2x more core for ARM. Now these extra computing power is surely going to help you scale better on ARM versus x86. The difference looks to be 2x on VM. With bare metal, this difference further increases. So we'll see, with how this particular extra computing power is going to help us. So this is a typical setup that we will be using. So this is all testing is using Sysbench. So most of us would be familiar with this. We would be using data which is of 69 GB in size. We will be testing it on two things. One is a CPU bound workload where we will provide enough buffer pool, and an IO bound workload where we will provide a lesser buffer pool. Redo log is good enough too. We would be using two different versions of MariaDB, 10.4.13 and 10.5.5. So 10.5.5 has some performance regression on the flushing front. So which is actively being fixed by MariaDB team. So just for a fair comparison, we will use one older version where this particular regression is not present. So we'll get a good idea of how ARM is performing. And we'll also see the result in 10.5.5 where also ARM is performing. So test scenarios, we will look into Sysbench, point select, read only, read write, update index, update non-index. Machine configuration, we have used a bare metal and we have applied the CPM model. So for the same cost, we could get 28 HT core of x86 and 64 cores of ARM. Okay, so that's the normalization done on using CPM. And storage, we have kept the same storage for both of it. The IOPS are almost or comparable on both of the storage. So that's the shot, that basically by keeping all the other configurations same, only by changing the computing power, that would make it easy to evaluate whether ARM really perform. Okay, so with that, let's see the results. This is MariaDB 10.4.13 workload, CPU bound workload. The the blue line represents ARM and red line represents x86. As you could see, almost on all use cases, ARM continue to perform better than x86. Importantly, with increasing scalability, the difference of performance further continue to grow and ARM continue to surpass after some point. In fact, for read-write workload, the difference continue to be better with significant margin with the ARM. And even for read-only workload bearing some small crisscross, we could see that ARM has been able to perform quite better on all the use cases. Now that's CPU bound. Let's talk about what about IO bound. So IO bound also present the same picture. As you could see, for all IO bound workloads, ARM, which is again a blue line here, continue to scale better and surpass or beat x86 on almost all front, including read-only and read-write. So this is MariaDB 10.5.5. As I said, MariaDB 10.5.5 has some performance regressions, which are being actively fixed. But I thought it is worth adding the results. And as you could see, even with this, ARM continue to beat x86 with increased scalability. So again, one thing which is prevalent is that on all these workloads, ARM scales better. Thanks to the extra computing power that is present for the same cost, that is making it scale so better versus x86. TPCC, so this is also gaining quite a lot of traction, or people do use TPCC also for a lot of validation. So I thought I will also add this results just to check how it does. And as expected, ARM continue to perform better than x86 quite significantly with increased scalability. Even for lower scalability, difference is marginal. I would not say it's a huge difference. So difference is marginal. And once a scalability point cross, then ARM just picks up and perform almost doubles the throughput compared to x86. Okay, so all these numbers, but then eventually probably we want to put them into some numbers using which we can justify the cost saving. So this is just an example. I have assumed the cost of the machine somewhere about 800 USD, and then I tried calculating TPS per USD. So I'm using one such data point, 1024 thread update index use case, and this is with 10.4.13. We use both CPU and IO bound. If you look at the numbers, then the TPS, that is transactions per second, given for ARM is always higher than the transactions per second for x86. Now that effectively means the TPS per USD is of course better for ARM, and that directly translate into a saving, because for the same cost I could get more work done from ARM versus x86. Now, typically, if you want to put it in another way, I would say there's a point when you would hit a threshold and you will have to take a decision that, well, I have to increase my computing power. So you have two options, right? So either you can go and buy a bigger x86 machine at extra cost, okay, and get your performance scaled, or you could simply keep the cost same and switch to use of ARM and still get a better performance or increase performance. So that way it directly translates into a cost saving. Even in form of clusters, if you have a master slave configuration, then of course you would find out there too, if you are booting a 5-node cluster of x86, maybe you'll have to boot a 4 or 3-node clusters of ARM, and which effectively will generate a significant saving. So from all these experiments, it is very much clear that MariaDB on ARM is a cost-effective solution as compared to the other flavors. So with that, let's talk about the state of the ecosystem, because when user adopt a software, he needs to also make sure that the ecosystem is up and running. So that's a quick intro about ecosystem. As you could see, the green blocks are already present on ARM. So server, of course, is there. Backup is inherent tool of server, and so is the cluster solution, whether it's Galera cluster multi-master solution or Binlog. They are part of the MariaDB default server. Things which are in red are not yet part of the ecosystem or have official packages on ARM, but they do work. For example, a few days back, someone from Percona actually compiled PMM or Persona Monitoring and Management tool on ARM, and was able to compile and get it running successfully. Now, with community support, we can actually make sure that all other remaining components also are made available on ARM in form of official packages. So the question is why we aim for completion, because if you are running part on, see, of course, you can still run part of these components on x86, because anyway, they will talk MySQL protocol, and they can communicate with the server on ARM using that protocol. But having everything on x86, on ARM would help you get significant cost saving. So I think that is the reason why we should aim for completion. There are other supporting tools of the ecosystem. Like, for example, if you are running on Kubernetes, it is available on ARM. If you use VTest for sharding, then probably it should get available on ARM. So with community support, we if we start asking, then respective organizations which own that tools or have been developing that tools could make them officially available on ARM. Same with migration tools. So that's why I say I think the community support is very important for upliftment of this ARM ecosystem. Whether, like we just talked about PMM, there's a Jira ticket open for max scale packages. So go ahead and like it. MariaDB will surely consider it if there are more community interest on making max scale packages available on ARM, connectors on ARM. As I already talked about distro, for distro we are already talking with MariaDB organization, and they are going to add more distros beyond CentOS and Ubuntu. So I think this is going to, community support will always help. And as I say, development still continues, right? So MariaDB, ARM is on their mainline plan. So they do consider ARM compatibility while they develop any new feature. The DB ARM community is growing. They have contributed a lot more performance patches, bugs, making sure that ARM64 wider hardware compatibility is possible, because ARM is an open architecture. Lot of companies develop their own ARM processors using the main design. So making sure that the software runs on all these ARM processors. And if you have any issues and if you wish to join or contribute back to MariaDB on ARM, there is a dedicated channel on community chat of MariaDB now, which is called MariaDB on ARM. So I'm going to end this talk leaving you with a message which says, let's make MariaDB great again on ARM this time. We all know MariaDB is great on x86. We are just saying that let's make it great again on ARM this time. Hope you all the community people would be able to support this. And next time when we talk about it, MariaDB on ARM would be the best open source DB available. Thanks for attending. If you have any questions, you can of course put it over Twitter. I have also an active blog. There's also GitHub. You can find my contact details also. So if you have any questions, of course, you can ask on the channel also and post it to me too. Thank you for your time, and thanks for attending the talk. Thank you.
Krunal Bauskar, thank you. Great presentation on ARM. You're calling in from Pune in Maharashtra in India, is that right?
Yes, yeah.
Good. So it must be late evening for you. I'll try to be gentle with you by asking a simple first question. So what is the general use case for using MariaDB on ARM?
So the main advantage that ARM comes up with is the cost advantage. You could save significant cost by moving your existing same setup, everything to ARM. And as we have shown even in our presentation, it could get you a significant saving.
Mm-hmm. Okay. So what kind of setups should one use MariaDB with ARM on? Like clustering, is it Galera or replication, or have you tried those clustering setups?
So yes, so internally I've been playing around with clustering setup, whether it's master slave or even the HA using Galera. So of course, in upcoming days I would blog more details about it, especially how they perform on ARM and all. So I think more or less they just work, as expected. But yes, of course, more detailed testing is needed.
Mm-hmm. And speaking of working as expected, what about builds of surrounding components? So let's say you have the proper builds of MariaDB, but there are other pieces of software around it. How many of them exist? And if they don't exist, are there any community build versions of them before the official repository version comes?
So I think there are quite few software, especially the way I look at it is monitoring software connectors. So those things are absent. Load balancers. So we are trying to work as a community. We of course are trying to connect with people to see if they could actually start providing the official repo. And individually as a community member, we are also trying to see if we can build them, and at least give all the steps for users to just go ahead and do it on his own. So let's see, as in I'm expecting that we will see a lot of these things coming from official repo in upcoming days also.
Mm-hmm. So then comparing MariaDB with, say, MySQL on ARM, have you done any comparisons performance-wise with like we do that with Intel? So have you done that on ARM? And if so, how did it look?
So yes, so if I get it correctly, we are trying to check out if we compare MariaDB on x86 and on ARM, and especially how they perform together, right? So
Relative
of
to
course, yes.
MySQL.
Right, right. So yes, so of course they do perform, as expected. I would say, and when we introduce MySQL aspect to it, right? So we also tested MySQL on ARM and MariaDB on ARM, and the advantage that MariaDB has on x86 is also carried on ARM too. So we don't lose anything by moving to ARM. That okay, well, suddenly on ARM MySQL get faster and or shows a different picture.
That's good to hear. So let's say then that I'm curious to start evaluating how to run MariaDB on ARM. Which version should I then try out?
So we have been trying around 10.4, 10.5 because most of the enhancements have been lately done to these two versions, and even the patches that we are trying to submit are also to these two versions. So I would suggest trying these. Going back to old, I'm not sure what kind of numbers you would see. So better go with the latest one, of course.
Okay. And speaking of latest ones, what are you working on right now? What kind of contributions and improvements are being worked out?
So we have been working on quite some improvements. We already contributed CRC patch. We contributed some other atomic related patch. Currently, we are working on, like last couple of weeks back, we contributed a optimized spin loop patch, which improved performance up to 12% on ARM. We have couple of more patches in pipeline around that, which could improve further performance. So most of the improvement things we are doing is around performance related things.
Mm-hmm. So, any feedback on the conference so far? Have you had any interesting interactions over Zulip with other presenters or attendees?
So, of course, everyone is excited. It is something new, something more promising, especially the cost aspect. And given that you get good performance, so everyone is excited. Everyone wants to try it out. I think the adoption will increase now that there are 3 or 4 cloud providers who are providing ARM instances. So we could see a lot more things in next upcoming years. So I think that's what the idea is. That's the message I'm taking. People are excited and people would like to try that out.
Good. Excellent work. Thank you, Krunal Bauskar. Very good presentation on ARM. Thank you.
Thank you.
Now for a look forward by Sergey Golubchik from the MariaDB Corporation, 10.5 and beyond.
Hello, welcome to the presentation about 10.5 and what's coming next. Let me introduce myself. My name is Sergey Golubchik and I was adding features to MySQL since 1998, and since 2010 I'm working on MariaDB. Now I'm a VP Server Engineer in MariaDB Corporation and a board member of MariaDB Foundation. So 10.5, main facts about it. We started working on 10.5 in May 2019, and in about a year we released a first J release, and as usual it will be supported for 5 years, so it will reach end of life in July 2025. In my opinion, the largest 10.5 feature is column store, so let's talk about column store. Column store is a storage engine for analytical queries. Imagine an analyst sitting at his laptop and cutting and slicing the data in various ways and grouping them and joining and ordering and stuff like that. This usually means static, mostly read-only data. This means complex select queries. And that means that you don't really know in advance what the analyst will do. So you cannot actually pre-create indexes in advance to optimize for his queries. And this is exactly the use case for column store. A bit of a history. Column store is not a new engine that we just quickly whipped up last year. It was under the name InnoDB. It was developed by Calpon since 2000 to 2014, according to Wikipedia. And under the name column store, it was developed further by MariaDB Corporation since 2016. And now it had reached a step where it could actually be added as a pluggable storage engine into MariaDB Server. A word of caution, because in MariaDB, plugins can have independent maturity levels. MariaDB 10.5 is GA, it's stable, but column store is at the moment only Gamma, but it's still quite usable and hopefully it'll be GA quickly. So what is column store? As you might have guessed, is a columnar storage engine. That means that values for all columns are stored together. All values for one column are stored together, as opposite to, for example, in InnoDB, where all values for one row are stored together. This works very well for analytical workloads, where the tables are often generalized with hundreds of columns, but you only want to look at a few of them. If you store separate columns, separately, then you only need to read the data for those columns that you're interested in, significantly reducing the I/O and making the queries faster. Also, storing all values for one column together makes compression a bit easier. So 10 times compression in column store world is not something unheard of, it's typical. And also, column store has some kind of indexes or index-like structure for those columns. You don't need to create indexes explicitly. In fact, column store doesn't even support explicitly created indexes. It kind of automatically indexes everything all the time, which is exactly what you need for analytical use case, because you cannot pre-create indexes in advance, as I just said. So column store fits this one very well. You can modify your data with insert, update, delete, but as it's again usual for analytical databases, column store has a fast bulk data loader, which allows you to quickly load a huge amount of data into column store by passing a SQL interface directly into column store. And as it's not very usual for analytical databases, or was not, column store can easily scale horizontally. If you have lots of data, more data than your workstation can handle, you can add another storage node and then yet another storage node, and then you have a storage cluster of nodes that your MariaDB server will be talking to. Also, you can add another MariaDB and yet another MariaDB, many MariaDB nodes talking to the cluster of storage nodes, so you can scale both on the MariaDB level and on the storage level. Column store is a really huge thing, and it deserves a talk on its own, and deserves many talks on its own, and we don't have time for that. So this is the URL to the knowledge base. Read the manual if you want to know more about column store. Another new storage engine in 10.5 is the S3 storage engine. It's designed for inexpensive, reliable storage of archival data. Like imagine you have some financial transactions, or I don't know, some visits to your websites, user clicks, ads, advertisements that you show, and you store your current data locally in your data center, and then you also need to provide high availability, redundancy, and stuff like that. And data for previous months you can upload into the cloud, into Amazon S3, for example, and then you'll have rather inexpensive and quite reliable storage of your archival data, and you can work with your infrastructure on your actual data that you modify all the time. So, as again I've just said, S3 storage engine stores data in Amazon S3. It can also use any other compatible storage that uses S3 compatible API. The data in the S3 engine are read-only, so after you upload the data into S3 you cannot change them anymore, but which is fine because those are historical data that do not change. And S3 allows shared access to the data. You can have many MariaDB servers accessing the same set of S3 buckets, so you don't need to duplicate the data if you want to access them from multiple places. Again, there's a knowledge-based page about S3 storage engine. There's also a Percona blog about it. You can check both if you're interested. Now, what new SQL features were added in 10.5, well, on SQL layer? I'll start with small and simple features, and then I work my way to the more complex ones and that I explain on following slides. First, database can now have comments. It was a contributed feature. There was a pull request. It's not something we developed internally. You can create and alter database with a comment clause, or you can use show create database to see the comment. All the table can now rename columns and indexes. This also should be pretty easy, pretty clear. Select uses set operations like accept and intersect since 10.3, and now they can also support the all qualify, not only distinct. This is SQL standard feature, and it was developed again not internally but during the 2019 Google Summer of Code project. Google Summer of Code student implemented it for us. Another 2019 Google Summer of Code project was insert returning. With returning clause, you can return a result set from insert that contains the data you have just inserted. It's particularly useful if you insert lots of rows and you want to know generated auto increment values. You just add returning and the auto increment column name, and whatever auto increment values were generated, you can have them as a result set from your insert. If you use recursive CTEs to traverse graphs, you definitely have faced the cycle avoidance problem. Now it can be solved more robust and faster with the cycle clause. And if you use application time period tables, we now support with overlap standard constraint. And more about it on following slides. So cycle. This is an old example of the recursive CTE from our recursive CTE knowledge base page. If you want to see the complete example, go to the knowledge base, but it basically has a table of the US city names and another table of bus routes between those cities. And this recursive CTE shows all the routes starting from New York. So first select New York, and the second one recursively appends the current city to the current path, and locate condition. It rejects cities that are already present in the path towards cycles. So there are a few problems with this approach. First, as you can see, after finding a perfectly valid route from New York to Boston, it also suggests to go from New York to Boston via Washington, which nobody really does. It's 3 times as long, and so it's kind of a useless path that we don't really want to see here. But this is a minor annoyance. The major problem is there's a bug here in locate. Let's say we also had, besides New York, Washington, and Boston, we also had Moreno Valley, California, and Reno, Nevada. This locate thing would find substring Reno inside the city name Moreno Valley. It would think that the bus has already been to Nevada, even though it hasn't. So this is just plain bug, and this is the old version of this recursive CTE from the knowledge base. In the latest version I fixed this bug, but there is no completely foolproof way to fix these string searches. They are inherently buggy, inherently problematic, and also they're slow, particularly if you have long paths that do the string searches all the time. This is just slow. This is what 10.5 fixes. See, this query rewritten, it removes locate completely and uses cycle clause. So it doesn't invent any more creative ways to go from New York to Boston via Washington, doesn't show this long path after it has found the short path, and also it's faster and it's bug proof as compared to the string searches. Now, as for without overlaps, let me first describe the use case here. Imagine this hotel booking system. So that's a table, it has hotel rooms, it has guest names, his check-in and check-out dates. And then we insert some data here. Alice checks into room 11 in October 1st and checks out on October 3rd. Then Bob will take room 12 from October 2nd to October 5th. And then Carol will take room 11 after Alice checks out from October 3rd to October 7th. And then Dave will check room 12 from October 4th to October 6th. And now if you following the dates, you would have noticed that there's a mistake here because Dave cannot check into room 12 because Bob didn't check out yet by October 4th. And with 10.5 we can make the database to check this constraint for us. First we need to declare this table an application time period table by creating a period of those dates. This way we tell the database that those two dates they considered a time period. This was possible in 10.4. In 10.5 we can add a new constraint. It's a unique constraint for room numbers and a period without overlap. That means that either periods should be without overlaps or room numbers should be unique. If two rows have overlapping periods, then those rows should have different room numbers, which is exactly what we need here. And if you would try to do those inserts into this table, you would get a duplicate key error, which is basically exactly what we need here, because Dave can check out in the room that Bob didn't vacate yet. Now, one of the most user-visible changes in 10.5 was the splitting of super privilege. Super is a quite historical privilege that existed for maybe 20 years. Over time, it accumulated all the different commands and activities that didn't quite fit in any other privilege. So it became a security nightmare because you cannot grant anybody fine-grained access to do something. You have to grant the whole super that allows the user to do all lots of kind of things. So we finally decided to bite the bullet and split the super into logically grouped activities, and every activity got assigned a separate privilege. For example, binlog monitor allows you to do show commands related to binlog, like show binlog status, show binary logs, show binlog events. And set user allows to change definer of stored routines and views. And I'm not going to describe every single one of them because, again, you can just check the knowledge base here. There were features that we have added to add more visibility into what MariaDB is doing, what's happening internally. And one of those features that was requested for quite a while is better performance schema support. More MySQL compatibility in the area of performance schema. We have added a lot of new performance schema tables to 10.5, making it basically MySQL compatible here. So if you have an application, some kind of monitoring application needs performance schema, it'll probably work with MariaDB out of the box. There are a few tables that we don't support yet, and we are working on supporting them. I'm not going to talk more about performance schema because there will be Valery Kravchuk's talk about performance, and he'll talk about performance schema in MariaDB. Also, we've added more tables to performance schema through information schema, providing more visibility into what thread pool is doing, and more status variables that describe various aspects of InnoDB, like memory consumption, net logs, again, exactly for this very reason, to provide more visibility into what InnoDB is doing internally. So now from performance schema, let's segue into performance improvements. Those are important performance improvements on the SQL server level. So until 10.5, you would do an order by, varchar 300, then every sort key would take 300 bytes in memory, and if you use UTF-8, it would be 900 bytes. And starting from 10.5, sort keys would only take as many bytes as the actual value takes, which means that usually MariaDB would put a lot more keys into one sort buffer. It would need to write much less data to disk, so the queries will be faster. How much faster, that actually depends very much on your application. In our benchmark, we have seen queries getting 5 times faster and 10 times faster and 10% faster, or not faster at all. It depends on the data type you're using, you're ordering by, on the character set. As I said, UTF-8 will get better speed improvements. It depends on number of rows on the table. It depends on how actually long your string values are. And also depends on what you're doing, what your query is doing, because if you do select star from a very huge table, then most of the time the server will spend sending data to the client, and any file sort optimization just won't be noticeable on that time. Another optimization affects everybody who needs to return numbers from the database, which I think is just pretty much everyone. In our simple select number from T1, we've seen 11% speed up by optimizing, removing unnecessary character set conversions for numbers. Now we've replaced PCRE, regular expression library, with PCRE2, and if you check regex engine machine speed benchmark, if you go for that, you'll see that PCRE2 could be sometimes slower. When both PCRE and PCRE2 are fast, then PCRE2 can be a bit slower, but usually it's faster. Sometimes can be 7 times faster if you do lots of OR operators. Depends on your regular expression. And by the way, note that all those improvements, they affect both single thread performance and multi-thread performance. It's what happens quite often, that if you want to improve high concurrency multi-threaded benchmarks like sysbench, then single thread performance, it basically goes down the drain. This is not the case here. All those improvements, they both improve single thread and multi-thread performance. And also parallel replication now is optimistic by default. It means the slave will try to parallelize as many transactions as possible, not following any more master concurrency. The slave will have a much easier time to keep up, even under load. So these were performance improvements on the SQL layer. There were also lots of improvements on the InnoDB layer, and I'm not actually going to explain them all. I just listed some of them, because there will be another talk by Marko Mäkelä who will talk about scalability improvements in InnoDB, and then he'll be talking about all those InnoDB improvements. So just watch his presentation if you're interested. Now, there are a few features that don't quite fit in any of the previous slides, so I'll just list them here. All the binaries were named to use a consistent naming pattern, MariaDB-something, like MySQL dump was renamed to MariaDB-dump, and MySQL_upgrade was renamed to MariaDB-upgrade. But there are symlinks to all names, so all the scripts and all applications will continue work as before. You don't need to change anything. But the plan is in the future to make those symlinks optional. So this is interoperability feature. If you don't want to install those symlinks in future MariaDB version, then you will be able to install MariaDB and MySQL in parallel if you would ever need to. We've added a new data type called INET6, which stores, not surprisingly, IPv6 IP addresses. Note that it doesn't just store them in strings, it stores them as 128-bit byte numbers. So the first 0 that I've inserted, it's stripped, and the number is printed in the IP address is printed in the canonical form. You can also see actual bit value, numeric value of the IP address, IPv6 address if you want to. But what's actually important here is that we didn't just add a new data type, we added a new plugin type, a new infrastructure for pluggable data types. So now it's much easier to add new data types, and you'll see more pluggable data types added in the future. You can add yourself more data type plugins if you need to in your application. If anybody still downloads binary tarballs, you'd appreciate that they become much smaller. And if you're using system versioning and you care about performance, then you probably partition by system time to keep history separately from the current data. And typical partitioned table look like it has one current partition and one history partition. Because this is such a typical use case, we simplified it and you no longer need to specify partitions explicitly. The MariaDB server will do it for you. You just need to specify tables partition by system time. If you want to have more than one history partition, you can do that too by just specifying the number of partitions. which is particularly useful if you want to rotate history by time, for example, like in this table structure, where every month of history is stored in a separate partition. There are other features, but we are running out of time, so I'm moving to the beyond part of my talk, beyond 10.5. And beyond 10.5 is, next release version is 10.6, so let's have a look. 10.6 facts. The 10.6 development branch was created in May 2020, but actually some of the features were in the development long before that for many months already. So it's not like we just only started working on 10.6 4 months ago. Now, I don't have a crystal ball, I don't know what will happen in the future, but if you look at other MariaDB releases, then they usually become GA somewhere in May, June, and they are usually supported for 5 years after that. So probably 10.5, 10.6 will be GA in May 2021, and it'll probably be supported until April 2026. But of course, I don't know. As usual, development happens all in public. So this is our Jira. You can search for yourself. You can search for fixed version equals 10.6 and see all the issues which were considered for 10.6. There are already, as you can see, almost 200 of them. So we definitely won't be able to do them all, and I'm not going to talk about them all. But this is my personal, highly subjective top 7 list of all those 197 features. The first one is, of course, the cross-engine alter table. This is something I wish we had quite a long time ago, and lots of users wanted it. It's when you alter a table and you can see it still continues to be writable until the alter operation finishes, and that's independently on what kind of alter you do. Even if you do it between different storage engines, you can still keep using the original table until the alter operation is done. Second one is atomic DDL. I don't quite need to explain that. I think atomic DDL is pretty clear, and it's a feature that you don't usually need. You only need it when you have a crash exactly during DDL, but when you do have a crash during DDL, then things can get pretty ugly. There could be data corruption if you are very unlucky. And with this MDEF implemented, then you cannot, because no matter when the crash happens during DDL, it cannot have data corruption or data loss. Keep sending metadata in binary protocol. It would be useful for anyone who's doing short selects, like point selects, and using a relatively modern connector that uses binary protocol. Because in this case, the metadata is sent twice, and it could be up to 3/4 of the actual data. So by skipping unnecessary metadata, we can send a lot less data over the network, and again, have the whole query round trip much faster. And another interesting feature would be adding support for JSON table. If you don't know, it's presenting JSON as a table, so you could do select from and then JSON. It's a SQL standard feature, and Oracle and MySQL both have them, and other databases. And users were requesting it. We are planning to have it in 10.6. Don't open partitions included by partition pruning means that if you have, you'll appreciate that if you have a table with lots and lots of partitions, maybe system version, I don't know, and you only need data from a few of them. Currently, MariaDB opens them all, but not open, I don't know, hundreds possibly of partitions that you won't be even looking at. You can shave a lot of time from the query execution. Execute InnoDB crash recovery in background means that, if you have a crash and then after the crash, MariaDB will start faster. It'll be serving queries earlier, and it'll continue InnoDB recovery in background. And the last one is, remember I just had a table structure with partition by system time, interval 1 month, 12 partitions. I get 12 partitions, and every new month of history would be going to the new partition. With this, when this feature would be implemented, I wouldn't even need to create 12 partitions, because every new month, MariaDB would automatically create new partition for the history. So it would make managing of partition system history tables much easier. But 10.6 is not only about new features. About half of the tasks are about refactoring. They are not generally user visible, but they improve code stability, they reduce number of bugs, improve maintainability, and quite often they improve performance too. I listed a few examples of those refactoring tasks from 10.6, but I'm not going to describe them. Talk to me on chat, write emails, check Jira if you're interested. So this is what we are working on in 10.6. But hey, you can participate too. You can suggest new features, for example, for us to do in 10.6. But yeah, you need to understand that there are already almost 200 issues and we won't be able to do all 200 anyway. So if you suggest a feature, it could just happen that it'll just fall below the priority level and just won't quite make the text, won't quite make the 10.6 deadline. Or perhaps your feature will be so awesome that we will decide to do it, absolutely do it at the expense of some other feature, then we remove some other feature from the 10.6 plan and we add your feature instead. So you can request a feature and you will see on Jira and you will see what will happen. Perhaps there's a feature that you definitely want to have implemented, and we decided that it doesn't quite make the line. You can just go on and implement it yourself and create a pull request. As you have seen on previous slides, we accept pull requests, and if it's good, it'll be in 10.6. If you just want to get your hands dirty and help us and implement something in MariaDB, but you don't have a personal itch to scratch, look for beginner-friendly label in Jira. It marks tasks that one can implement without prior experience in MariaDB source code, so even junior developers can usually do them. So talk to us. You can talk to us on Zulip, you can write a mail to Maria developers list. We are always ready to help.
Sergei Golubchik, thank you. We've now moved from Pune, Maharashtra, India to Karpen, close to Cologne in Germany. Welcome to the Q&A session at the MariaDB Server, Sergei.
Thank you for having me.
So, I was thinking about clarifying one issue here related to the roadmap in as much as it's about software maturity. So, you're talking about column store and those talk about S3, and these seem to be having a different level of maturity, not production level, when the surroundings 10.5 is in production. So do they have independent timetables for being declared production level, and if so, why?
Yes, in MariaDB plugins have independent maturity levels and independent life cycles, independent. They could be developed with separate speed, completely unrelated to how the server is developed. One can query information schema to see the maturity level of each plugin, and this means we can load a plugin we can add a new plugin to the server at any point in time, even after GA, even if plugin is not itself GA. And plugin can mature, go from alpha to GA much faster than the server, because new plugins are usually developed in very agile manner. And so it gives us and users more flexibility, and users can get new features in plugins faster. But that's also a safety switch that disallows loading immature plugins into a mature server, but it can be disabled if the user wants it.
So a plugin would be a column store, a plugin would be S3. Would you have other examples of plugins?
Well, I mentioned in my talk we have added a new data type plugin. There will be more data type plugins in the future. There are a bunch of authentications plugins in the server, but they're probably all already mature, not the LGA.
Okay, so then looking at the roadmap, you mentioned some things about what ended up on the roadmap for 10.5 and some of the thoughts on what is ending up on the 10.6 roadmap. You also mentioned that, but what's the process like? How is it selected? What comes into the roadmap?
Well, I mentioned in my first slide that I'm a board member of MariaDB Foundation and I work for MariaDB Corporation, so I can explain this process from both sides. Foundation, it primarily listens to what users want. It looks at pull requests, and well, it can accept pull requests, review pull requests. It also has developers that implement the features and listen mostly to user requests, or what is more important to MariaDB Server more popular. And MariaDB Corporation does all that as well, but it being a for-profit company, it also has paying customers, and additionally, it listens to the requests and desires of their paying customers, and quite understandably prioritizes their feature requests and whatever paying customers want to have.
Okay, so if I'm a sponsor of the MariaDB Foundation or just any general community member who believe that I'm good enough to create code that I hope to be part of MariaDB 10.6, what does the process look like? When do I need to come with my contribution in order to stand a chance of seeing my contribution?
That depends on the contribution size, because usually a contribution is not getting accepted right away. It happens extremely rarely. Usually there's a review, and then there are minor comments or larger comments, different number of comments, sizes of comments, and then maybe the contribution needs to be fixed or completely rewritten, or it can be rejected outright. And it just happens that if contribution is very large, then it usually will take more time to stabilize, to be approved. And the feature, we plan to stop adding new features into MariaDB 10.6 somewhere early next year. So if the contribution didn't come through the whole cycle, didn't get a reviewer's approval by that time, then it will quite possibly miss 10.6 deadline.
Mm-hmm. So then I'd like to move to an adjacent but very related area, and that's security, because I think security affects both minor releases and it affects the roadmap in general. It affects the work of what comes into the code, especially the release cycles. I've seen these quarterly releases. Is that just what's the reasoning behind that, and where do the contributions to security fixes come from? How are you alerted to security bugs, and do you take like the Oracle quarterly CPU things for MySQL? What's your take on that, and what's your role in this security perspective?
Yeah, yes, this is a very appropriate question for me, because I was in MySQL times, I was the person behind security@mysql.com for like 10 years, and now I'm basically replying to server emails at security@mysql.org and develop security-related procedures back in MySQL times and now in MariaDB for the last 10 years. So yes, we do look at Oracle releases critical patch updates with list of security vulnerabilities, in particular in all Oracle products, in particular in MySQL, 4 times a year. And I don't remember exactly the date. It's like second Wednesday or second Wednesday of the second Monday, I don't remember. It was in July, in October, and in April and January, I think. So the next one will be in October. And after that, after they're published, I look at MySQL releases. I map the changes in the code to security vulnerabilities in Oracle CPU. I take those that apply to MariaDB and I add them to MariaDB, and then we release. If we won't release very soon after Oracle CPU, then users and paying customers and Linux distributions, they start getting very worried, because they will know that MariaDB has like published known security vulnerabilities that we don't fix. So we need to be very quick and release as soon as they are getting published.
And you do that for earlier releases, not just so which releases do you release the patches for?
We really, well, for everything that is supported, starting from Gen 1 to Gen 5. We do not do that for the development release, because it's not supposed to be used in production anyway.
Excellent, great answer.
but it's getting easier and easier with time because less and less security issues found in Oracle MySQL, they apply to MariaDB. We keep a page in the knowledge base so that you can easily check whether a particular CVE was fixed in MariaDB or it just didn't apply to MariaDB at all.
Apply to us. Okay, great. Thanks for educating us also on security issues, Sergei Golubchik in Karpen, Germany. Thank you.
Thank you.
Now for some ML. Jorge Torres. AutoML in MariaDB. Train and query machine learning models straight from MariaDB.
Hi, my name is Jorge Torres, co-founder and CEO at MyNCB, and I'm here to present to you machine learning in MariaDB. We're going to cover the agenda first. We're going to talk about why bringing machine learning to databases, why we think that is important, and we're going to introduce a concept called AI tables and how we implement it in MariaDB, as well as walk you through a demo. So the first thing that we're going to walk you through is why machine learning model in databases. And anyone that has dealt with the creation of a machine learning model understands that data is the crucial ingredient to machine learning. And the reason for this is that you really need data to train your machine learning algorithm to do what it's supposed to do. Then it becomes intuitive to us to ask the question, well, why not bring machine learning as close as possible to where the data lives? And given that a lot of the structured and organized data already lives in databases, the idea came to why not just bring machine learning straight to the database itself? Like, why not? And perhaps allow people to train and use machine learning models straight from the database. So can we do this? Is this even possible? And when we were asking ourselves this question, we thought maybe we can start thinking of machine learning models as if they are tables. And let me explain this to you. Like, you can actually take a machine learning model and query it if you could. And on the query where statement, you can pass the conditions for the model to make a prediction. And then on the select, you're selecting whatever you want to predict. And if you're able to do this, to treat machine learning as models, then all of a sudden you're kind of simplifying the access to the model and the way that you're making predictions. The next question that we had is, how do we call this fancy tables? And the name that we came up with was AI tables for simplicity. And that's what we're going to explain to you. But if you have an AI table, still you have to train this model, or you have to create a model, train it, test it, and validate it, and expose it as an AI table. And even though a lot of people may like the idea of doing the machine learning part themselves, machine learning can be hard and requires extra expertise. And for a lot of people, this can be quite a hassle or quite a pain. And we thought that if we're really going to do this, we also have to simplify that part. So how do we simplify the model creation, testing, and training? If you think about it from the context of a database and doing machine learning with the data you have in the database, a lot of the problems can be thought as you want to predict a specific variable or column, and you want to use the information that you have in a query or in a database table to learn how to train this specific machine learning model. And then you would like to expose that trained model as an AI table. So we thought about this for a while, and we realized that perhaps a simple way to do this is to bring AutoML into the mix and use a simple insert statement that does exactly that. So you insert into a magic table called predictors, where you specify the columns that you want to learn and the data that you want to learn from, and the name of the table that you want to expose this as. And doing it actually makes it easy for anyone that knows SQL. They don't have to have any extra skills, and they can now use the power of machine learning through their normal tools that they know how to use already. So once we realized that it was possible and that these mechanics will enable you to not only use a machine learning model within a database through this concept of AI tables, but through normal SQL, you can create, test, and train and validate models and expose them. Then we thought of how can we actually make this a reality. And the cool thing is that MariaDB has this connect engine, which allows you to bring into MariaDB information that doesn't live or exist inside MariaDB. And we leverage this capacity so that we can actually expose machine learning models as tables. So when you query the model, it looks like an actual table, even though it's running on the MariaDB AutoML framework. And on the other hand, you can also, once you have like the idea of what you want to predict, we expose this magic table called predictors, and you can insert into this table, and MariaDB will figure out, what it needs to do to actually create the model, test it, train it, validate it, and expose it for you. So now that we've covered how we're doing this with MariaDB, I think that the best step will be to walk you through an example. Before we start into the demo, let me walk you through the use case here. Imagine that you have a website that sells used cars in the UK, and you've been collecting data for a while about the different attributes of the cars and what you end up selling them for. And the problem that you want to solve is you want to, given the inventory that you have of cars that you haven't sold yet, what will be the best price to sell these cars for? So you have historical data. This is a perfect machine learning problem. And you want to learn from this historical data so you can get a good prediction of the right price to sell a car for, the price range that will be ideal. So in my screen, you can see on the top the configuration file for MariaDB. MariaDB, again, is our AutoML framework. And it's actually very simple. Once you have MariaDB installed, you just have to tell it how to connect to your MariaDB server. For the sake of this example, I already have MariaDB installed as well as a MariaDB server. Again, the way that we connect to MariaDB, or that we integrate into MariaDB, is by using the connect engine. And to do this, we mimic the MySQL TCP/IP protocol so that when you connect to MariaDB, it looks like an actual MySQL or MariaDB database. And when you see the tables, you're actually looking at models. Now, once you start the MariaDB server, what it will immediately do is that it will see from the configuration if there are any databases that it should be connecting to. And what it's going to do is going to publish a table called predictors into the MariaDB database that we have here installed. And this table doesn't live in MariaDB. It's a table that lives inside MariaDB. And this is the table that we use to create new models. Again, for the sake of this example, we have a database called used cars. And in this database, we have all the information that we need to learn from. So what we're going to do is we're going to tell MariaDB to create a new predictor and expose it as an AI table and what query we are going to use to learn from. Once you do this, MariaDB handles the rest. So it takes the data that you have and splits it into train and test and validation sets. It analyzes the statistical properties of the table, and then it generates the best pseudo model for this and trains that model. Once the model is trained, it publishes this as an AI table as you specify it in the insert command. And then you can look at this AI table as if it was a real table inside your MariaDB instance. This is really cool because then now you can make queries to that table, but that data doesn't live anywhere. It's being generated on the fly based on the parameters that you pass in your where statements. Now, when you're making a query to an AI table, you can query the predictive value or variable that you want to predict, but you can also select other columns that we provide for you, such as the confidence interval, and an explainability feature that we have for that prediction. So you can actually understand when you can trust or not trust the actual predictions that you're getting. MariaDB is clever enough to understand based on what you're asking, what information it should generate for you. But ultimately, what you have to understand here is that machine learning models can only be as good as the data you provide for them, and they can be really good at times or not. And the key element of MariaDB is to be as transparent as possible about the confidence that you have for a specific prediction, as well as to exposing information that you may find useful to your decision-making process as to whether to trust or not trust the model. And I think that the best way for us to see this through and also to walk you through the different elements that involve machine learning is that one thing is to have the predictions and to be able to create the models from the database and use them straight from queries. But the other element is you need to really understand and explore the model. So after I walk you through these examples, I'm going to also show you some of the explainability features that we have around MariaDB, so you can do both things that are really important in any data science problem, that you can create the model, test it, train it, validate it, do all these things, that you can actually access these models straight from the database, but also that you can trust and build some intuitions around the models. So MariaDB comes with a graphical user interface called MariaDB Scout. You can download it from our website. We'll pass you all the links, but once you do this, you can connect to your MariaDB server. And what you can see is that once you create a specific model, it also gives you a data analysis tool about the data that you use to train the model. And essentially what here it does is that it will analyze the statistical properties of the data that you pass into the training phase. And it will give you warnings such as potential biases or potential outliers. Now, once you have a model trained, it will tell you what is the overall accuracy of the model, as well as what information for this specific model was important, and when can you trust the model, when you shouldn't trust the model. So as you can see here, there's an area within the price ranges that you have where the model is not really that good at learning, but on the rest it is. And you should take this information into account when you're actually making a prediction. You can also kind of do some sensitivity analysis on the model from the graphical user interface. You can do this straight from SQL, but you can do it from the graphical user interface itself, so you can get extra insights about explainability. Now, I think with this, we cover kind of like the different pieces around MariaDB, and we're looking forward for you to share and try it, and also give us feedback about what you think. So very excited about this integration, very excited about what you guys are going to build with MariaDB, and please join our community, join us in GitHub, and write us and come to us if you have any other questions.
Jorge Torres, MindsDB, calling in from Austin, Texas. Welcome, Jorge.
Thank you, Kai. Happy to be here.
So I'm sometimes a Python programmer, and machine learning often fits into Python. And what I think of then is memory structures in Python and logic in Python. So where does the database come in here? Why a database and why MariaDB?
Yeah, anyone that has done machine learning knows that you cannot do machine learning without the data. And more importantly, organize data. Regardless of the machine learning task, you need to organize your data somehow. And a database is where a lot of organized data lives and where people operate on a day-to-day basis when they have a system that is operating. So we couldn't find a better place to bring machine learning to than the database itself. And MariaDB is particularly interesting because it has the Connect engine, which allows you to bring tables that don't exist inside MariaDB. And we use it as a hack to create this concept called AI tables. And the difference between an AI table and a normal table is that an AI table doesn't really contain any data, but when you query it, it generates a prediction. So it felt like an elegant way to bring machine learning in a seamless way to the database and to MariaDB.
So this seems to me that you're using the database for two purposes. One is a data source, and then the other one is as a sort of the result user interface to query the outcome of your analysis. Exactly.
And when the second part of doing machine learning is moving into production, but if it's already embedded in the database, then that step is seamless too.
Mm-hmm. So then I'm thinking about your engine, your machine learning engine, and the configuration of it. So how do you separate between what your product does, your engine does, and what the DBA, or probably more ML administrator, your machine learning administrator, has to do or configure? What's the role division there?
Yeah, so you can install MariaDB as a standalone server. It can run in the same machine that you have your database, or in a separate machine. And this allows for you to like truly separate the computational power if you want, so you don't overwhelm your database server. And what MariaDB takes care of is once you have the data that you want to predict from, then MariaDB can generate a model automatically for you, and then test it, train it, expose it to you. And the database or the DB admin, they only have to care into plugging MariaDB. Once it's plugged, then they can treat the machine learning tasks like generating a model or querying that model as if they're dealing with regular tables inside MariaDB.
Mm-hmm. So this then, of course, must mean something for the performance. Let's say I have a normal database, and then I turn on MariaDB, and it observes data to learn from it and to be able to predict from it. How do I understand how much it affects performance?
Yeah, that is a great question. So it really depends on your problem. If you're dealing with a really big table with a lot of columns, a lot of rows, to train, this can take a lot of time. Also, depending on the type of columns that you have, if you have like text, it can get heavier. If you have images or like URLs to images, then that can also increase your computational needs. However, that's the cool thing about being able to separate that into a separate instance if you want. And MariaDB can run a cluster in itself, so it doesn't have to, again, take resources from your existing database resources. Mm-hmm. On the other hand, what we want to ensure is that every problem is different, and we are not claiming that we have a one model fits all, but the model is generated on the fly depending on what you fit into MariaDB.
And your crystal ball predictions, how accurate are they?
Yeah, that's a great question. It really, again, depends on your data and what you want to predict. So we do try our best to generate the best model that we can for the problem that you want to solve. Say, for instance, you want to predict inventory. Then if your data is, the data you have is enough for you to get good predictions, then it's going to be fairly accurate. But if you're going to make a prediction, but you don't have enough data, MariaDB will also tell you that it's not that accurate or not that confident about the predictions.
To get the measurement of the accuracy as well. So, but you were mentioning also that your model might not be the only one. So if, can I build my own model and then still use MariaDB somehow?
Yeah, of course. So we want to enable this capacity for people that are already doing machine learning separately, and they just want to have this capacity to integrate into the database. So you can plug, for now, scikit-learn or PyTorch models into this. So you can, once you train a model, we'll provide documentation well on the website of how to upload your models. But yeah, certainly you can. And you can even benchmark them with what MariaDB can generate automatically, so you can decide what's best for you.
And there's sort of an API for that, or how is the interfacing done?
Yeah, so MariaDB comes with a RESTful API, and it has basically two main resources. Like you have the predictors or the models, and you have the ability to kind of like tell it from what data you want to learn. So like the data sources, and within that one, in the model one, you can upload a new one. So long you follow the steps. It's a very simple Python file that you have to generate, zip the whole thing, and you upload it. Yeah. Mm-hmm.
So you said in the beginning that you're using, or the end user of MariaDB is using it for two purposes. One is for training, for feeding the model with data for it to learn, and the other one to serve the results by selecting from fictional table that then give the answer. So can I train the model, the first part, with other data sources than directly the normal MariaDB ones?
Yeah, you can certainly do this. That's something you can do either, again, still even through the integration that we have with MariaDB, or you can just do it through an interface that we provide for you or the API. So the training part can be separated, and then you can publish the model into MariaDB as a table, as an AI table, how we call it.
Cool. Hey, I hope you get more questions still than my simple ones, the difficult ones over Zulip. So do stay tuned on Zulip, Jorge, so you can get some cool questions and give answers to those who have deeper problems than my superficial ones. So thank you very much for very clear answers, Jorge Torres, MariaDB.
Hi.
Now we have MariaDB Foundation's very own Robert Binder, bringing MariaDB closer to the data science community, the MariaDB Jupyter kernel.
Hi everyone, and welcome to our online fest. My name is Robert, and my talk today is focused on a new project that we are working on within the foundation, and that is called the MariaDB Jupyter kernel. A bit about Project Jupyter. Project Jupyter is an aggregation of tools which are built on top of IPython, the interactive Python interpreter. Everything under the Jupyter umbrella is open source. Everything is licensed under BSD3. And let me tell you something. This is a very popular project, and it is also extremely cool. It has the capability to change a lot, how we currently teach people in school, how we currently train employees, and it can also bring a huge chunk of transparency into the scientific research practices. The Jupyter products are designed to be quite extensible, and the good indicator of this is that there are, at the time this video was filmed, around 144 open source kernels for Jupyter Notebook, and these are developed by the community. Yeah, you actually heard that right. That is 144 programming languages and other technologies that notebooks can speak fluently. The most popular product of Project Jupyter is the notebook. It is a quite complex JSON document which contains code, results of execution, images, and other media. The notebook is the building block for every Jupyter product. Everything else is built on top of this concept. The capital N notebook is a client-server web application. This app knows how to render the notebook documents. It's the editor where you can write your code, execute it, and get the results instantly. The next generation of this Jupyter application is called Jupyter Lab, a more complex interface for notebooks, but still a single user application. The most complex one is called Jupyter Hub, a multi-user application with many authentication methods, and that one can be deployed pretty much anywhere. And it can also serve very large crowd of participants. An honorable mention goes to the mybinder.org project, which serves the exact purpose of transparency I was speaking about earlier. It can take a GitHub repository full of notebooks and turn it into a live web application so that other people can reproduce your results with just one click. The Jupyter products are used, as far as I'm aware, mostly to teach university classes, online courses. It is also used they are also used in employees training programs, but they are also used massively in data science applications. I've used them myself quite a lot during my university classes a while ago. Anyways, due to their application in data science, where problems are run against massive sets of data, and due to the effectiveness of MariaDB in dealing with data, I have the feeling that these technologies should become very close friends. What is a kernel? A kernel is a program and also a process within a Jupyter Notebook server, and this one is capable of understanding and executing the code that you just wrote in your notebook. Your Jupyter Notebook web page sends the data to the notebook server, which then forwards it to the kernel and transfer back the results of the execution into your browser. And that's pretty much what it does. To speak about our motivation for this project, not so long ago, I ran an experiment in which I computed various metrics and charts for our community contributions for the MariaDB Server repository. I used Jupyter notebooks, and because of this, these statistics are easily reproducible every year whenever we need them or we want to compute them. And this helped us understand a lot what we need to do to be a better open source project. Kai, our CEO, is also a big fan of Python and notebooks and uses them in a lot of scenarios, such as displaying charts for his running activities and for building kayaking maps that he plans to follow during vacation. In any case, these past experiences converge into the idea of a MariaDB Jupyter kernel, and we plan to build it in the Jupyter spirit. That is extremely easy to use and extend, have it open source, and also be good looking. And so we started. After some design meetings, a lot of research, and a sprint of coding, we managed to create a working prototype. Let's have a quick look at it. I'll open a terminal window first. Let me just make it visible. Okay. So I already have a MariaDB server running and also MariaDB installed, but you'll also need to make it work. You'll also need to have Jupyter Lab installed. So let me quickly connect to the server and try to see the number of clients connected. So I just run the client. And I type show global status like threads connected. And as you can see, there is only one client connected. It's actually this one. So let's close the client and start Jupyter Lab. Just a second. A new browser tab was opened. Oh, let me turn off the terminal first. Yep. So a new browser tab was opened. In the main window here, you can see a list of kernels that you can choose from under the Notebooks tab. I have a Python kernel here. Some C++ kernels because I installed a custom C++ kernel some time ago, and also on the right there is a MariaDB kernel. Let's click on the last one. So a new notebook was started, and this one is actually using the MariaDB kernel. Let's open the terminal again and see if the number of connected clients changed. Let me make it visible first. Okay, hope it works. Okay, let me split the window, connect again, client MariaDB, and run the command again. Should have it in history, yep. Okay, so as you can see, now we have two clients connected. This means the MariaDB kernel actually connected to the server successfully. Good. Let me hide that again and go back to the notebook. Hidden. Yep. So as you can see, the user interface is actually good looking. We can choose, for instance, to create another notebook in a separate tab, and let's do that. Let's create a new notebook, but this time let's have a Python one. So we switch back, we hit File, New Notebook, and the Jupyter Lab prompted you with a menu, a drop-down list, where you can actually see the list of kernels you saw earlier on the main page. We have the Python, the C++ ones, and MariaDB. Let's choose Python. And now we have a new notebook which is running the IPython kernel. So let's quickly test it. Let's do some dummy prints. Print 3, and if I execute the cell, I get the result. And let's try a small experiment where we try to chart something. So let's do this from matplotlib lib import pyplot as plt, and then create a small array 1, 2, 3, 4, and do plt dot plot of x, and if I execute the cell, I get a new chart. It's actually very, very easy. It's cool that you can do something like this with just a minimum amount of lines of code. That's actually very cool. So in MariaDB we can do pretty much the same thing using SQL. So switching back, I can write the simplest query possible, select one, I hit the result, I get the result here. But let's also try to write a query that returns a bit more complicated result set. So let's select star from mysql.db, and as you can see, the kernel return a result set in a nice table which is scrollable. You can walk over the lines, they are highlighted, columns are highlighted. That's actually very cool. So you can also, of course, do pretty much anything a modern editor does. You can go back and change one of the cells and re-execute it. Let's actually just do that. So you can go back here to select 2. Now we have the new results. The prompt moved to the new cell. I can hit again Shift Enter and results are re-evaluated. So that's cool. You can also save the notebook and share it with someone else. And a nice tip for this is that a while ago GitHub implemented native support for rendering Jupyter notebooks. So you can just push your notebook file into a GitHub repository, and that's it. Everyone can see the notebook as it actually appears in GitHub. So that's actually very cool. Another cool feature here is that you can change the type of a cell in the notebook. So you can move it from code to markdown, and this is really useful for creating nicely documented notebooks. So let's do that. So I have the new cell here. I change the code to markdown, and if I type using the markdown syntax, we've just ran a query using the MariaDB kernel, and I execute it, I get a line. Oh, I have a typo actually. So I get a line that is looking like markdown, and that's actually very cool. So in the near future, the MariaDB kernel will support a set of magic commands. It doesn't currently support at the time this video was filmed, but I'm pretty sure by the time it will be streamed, the features will be there. So in any case, we will provide a set of magic commands for integrating your SQL with libraries such as matplotlib, and also with other Python kernels. So let's do some fictive examples. So let's say you have a query like select 1, 2, 3, 4, 1, 2, 3, 4, which returns a data set similar to the one we used in the Python kernel. And with the line magic command, if you type line and execute the cell, you would get a nice chart, pretty much the same like you got it in the Python notebook. Another thing, we plan to implement df magic commands, which is looking like this, and you'll be able to write df and something like SQL data frame and execute the magic command, and this one basically takes the result of the last query and exports the data set in a nice CSV format file, which you can easily import into the Python notebook. And you can do it with something like pandas. Actually assign it to something. df equals pandas read CSV, and have something like data frame .sql, which is the name of the one we created in the MariaDB kernel. So executing this will just import your data that you had in the MariaDB server, and you can continue doing your Python magic from here, which is awesome. So yeah, let's move on. Sorry, let's close this tab, leave. Okay, so as I kept speaking about magic commands, let's see a bit what these features actually mean. So magic commands originated in IPython, and they are basically some shortcuts that you can use to make your life easier. The Jupyter kernels are entirely responsible for implementing their own magic commands. Unfortunately, there is no IPython magics that are inherited for free. There are two types of magic commands as they were originally defined. You can have line magics, which are pretty much independent. They do their function on their own without needing any extra input, except for the arguments passed on the same line with the magic command. And you can also have cell magics, like the bash one you can see here in the slide, which takes as argument the entire code from the cell. So more exactly, in this example, the bash magic lets you write bash script within the cell, and when you execute it, the bash code is executed using the bash process, and that's very nice. And as I said earlier, they are designed to make your life easier. They are mostly their main purpose is to access the language powers faster. But they can also change the behavior of the kernel, or they can help you create bridges between multiple kernels for different technologies. And the cool side effect of these magics is that they are pretty independent mechanisms, or at least we designed them this way. So this means everyone can contribute their own magic to a kernel without too much effort or interference with other magics or functionalities of the kernel. Oh, that's a nice side effect. As for the MariaDB kernel, we plan for the first release at least a set of matplotlib magic commands and a magic for helping you bridge the MariaDB kernel with Python notebooks. But we also have a lot of interesting ideas, like switching between client connections on the fly, or even running small Python scripts directly from your MariaDB kernel. The kernel is written in Python, so that should be possible, right? I would love to hear some of your ideas too. Help us make this kernel as rich as possible, even with ideas, so it gets to help more people too. So if you love this idea so far and you'd like to play around with it, it is pretty simple to get started. You need to have MariaDB installed locally, and also you need JupyterLab. Currently, you need to install the kernel by cloning the repo and by running pip install locally. Unfortunately, at the time this video is filmed, packaging for Conda and PyPy isn't ready yet, but we are on our way there very fast. The complete instructions for installation are on the main page of the repository. Please take a look if you'd like. And I would love to dive with you a bit deeper into how the kernel works and fits inside the Jupyter Notebook ecosystem. So in the top part of the diagram, you have your browser with the JupyterLab or Notebook web application. So when you write your code inside the notebook and you execute a cell, the web app sends a message to the server side of the notebook containing as payload the code you just wrote. And when the message hits the notebook server, it is pre-processed and immediately forwarded to the already spinning MariaDB kernel. Behind the scenes, the kernel implements a well-designed communication protocol, and a very well documented, by the way. A good job for Jupyter for doing this so well. Thanks a lot. And for a lot of the actions you perform in the web application, a similar message to the above is propagated to the kernel. Some examples might include code execution, autocomplete requests, stopping or restarting the kernel, and many more others. when the kernel receives these messages, it reacts in some way. From this point on, it is the only entity responsible for what the user experiences when the reply gets back to the browser. For code messages, for instance, the MariaDB kernel parses the payload and determines which parts of it contain SQL code and which parts of it contain magic commands. To execute the SQL code, the kernel performs some preprocessing, connects to the MariaDB server running somewhere, sends the code for execution, and gets back the result. And it does so in the simplest possible way. It directly uses and controls the classical MariaDB command line client that you all know, and it uses it as a subprocess. And as you most probably know, the MariaDB client is capable of talking to servers anywhere, and it is very efficient at doing this. So the Jupyter kernel inherits this all for free. For executing magic commands, the kernel is on its own mostly. This means it needs to parse them, understand their meaning, given different parameters, execute them and package the results in a nice compatible format with the notebook protocol. But because the kernel itself is written in Python, it gets access to a lot of the perks of being a Python program, meaning it can easily talk to charting libraries like matplotlib. It can easily export data in a easy to process format by other Python notebooks. So it gets a lot of perks. And this is pretty cool. You can access data using MariaDB Server speed and proven reliability from your favorite notebook interface, using the SQL language you are very familiar with. And you can just switch the tab to a Python notebook, import that data, and perform analytics on it with very few lines of code. That is very cool. This project is still in very early stages. I advise you not to use it yet for more than playing around and see what it's capable of. But I encourage you a lot to do play around with it. By doing so, you are directly helping us to make it better and useful for more people. Also, I would love to see if you can find other use cases for the magic commands. Feel free to just open a pull request for a new one that seems useful, or just let me know in an email or message or something, and I'll try to make that happen for you. As always, we are thankful to our sponsors who helped us get here. It's always a joy to see lots of effort put into the same goals. That's very nice. And that's pretty much it. I hope you enjoyed this small intro into the MariaDB Jupyter kernel. Thanks a lot for taking the time to watch this presentation, and have fun for the rest of the fest. See ya!
Robert Binder on Jupyter. Welcome, Robert. You're calling in from southern Romania, are you?
Yep, that's right. Hi, Kai, and nice to see you in New York today.
Yes, virtual New York. Yeah, so there's a common denominator between the previous speaker from Austin and you, and that is Python. The Jupyter is spelled with PY. So is this a trick Jupyter a trick to persuade millennials to start using something that looks like a command line, or is this a better command line interface for those who learned to program sometimes last century, like me?
Yeah. So when we first came with this idea, we designed the kernel for the Jupyter users that want to try out MariaDB. But if you are one of the more senior MariaDB users that is using the classical command line, but you also love user interfaces, you can try it out. Also, if you like to play around with your data and perform analytics, this will be a very good place to start.
So it seems to me like this is the intended for both, but primarily you spoke about data scientists, so to make it easier to use MariaDB as a data scientist, that's the primary use, but hey, any user of MariaDB can also benefit from the Jupyter kernel, right?
Yep, of course, yep.
So when can I get it?
Well, so you can already get it. The code is public on a new GitHub repository with everything we've done so far. So you can already install it, but you need to clone the repo and run the commands that are available in the installation instructions in the repository. But you have to notice that it is still in the very early stages, and our first release will come probably sometime in a month or so.
Okay, and where can I get that one then? I mean, if you say that now I can already clone a GitHub repository and do some manual work and get it to be tested, but where can I get it then later on?
Yeah, so now you can get it by what is called through a local installation with pip. So you could basically clone the repo and you use pip to install from the local copy of the project. But afterwards, we have in plan, and this is one of our core values for this project, is to make it as available as possible and as easy to use as possible. So we'll prepare PyPy packaging and also Conda packaging so that you can install it with just one simple command, which is very common in the Jupyter ecosystem, and we love this about Jupyter.
So pip now and Conda later.
Yep. Actually, pip now and both later.
Pip now and both pip and Conda later. Sounds good. So it's been a while since you recorded the film, at least weeks. Has anything interesting happened with the code base since you recorded the film?
Yeah, so I actually got a bit more time to work on the project, and I managed to deliver the magic commands that were pitched in the film, and that is the matplotlib charting magics like line and the DF for exporting the data into CSV file. But also I added some extra so this feature was already on our roadmap, but it wasn't that high priority. But to make my development process easier, I implemented it, and this is the ability of the kernel to detect if there is a running MariaDB Server instance, and if there is not, to launch an instance for you, so that if you're a new user and you want to try out something, you just start the Jupyter Lab and the kernel, and it will launch a server for you, and you can quickly test whatever you want to test.
So this seems like it's going to be, or already is, native MariaDB select statements that you say, as opposed to, there was another presentation here on the MariaDB Server Fest by Robert Hedgepeth about SkySQL, and he also showed a Jupyter network kind of thing, but to me it seemed like he was just connecting over Python. Now you're connecting and talking native MariaDB. And as I understand you, this is not just for people coding Python, am I right?
No, of course, no. So it is intended for people that love Jupyter and Python, but using the kernel, you can just write plain SQL statements like you write in your classical MariaDB command line client. But it is of course enhanced with some nice UI features like displaying the query results nicely and the magic commands and so on. But yeah, it talks natively with the MariaDB server through the classical command line client, which it controls as a subprocess.
So this really is an enhanced command line interface with.
Indeed, it's a nice wrapper that allows us to expose MariaDB into the Jupyter world, and I love that it was so easy to do this step and expose MariaDB into the data science world.
And platform-wise, as I understand it, you're sort of using it from a browser, or how do you use it?
Yeah, so the most common use case is to launch Jupyter Lab, which will basically behind the scenes launch a web server and open up a page for you that connects to that web server, and you can use you can use the kernel functionalities from the browser, which is a nice feature because it kind of allows us to be available on as many platforms as possible.
So a new command line interface for data scientists who are going to have an easier time using MariaDB, but also, if I understand you correctly, it's a better command line client because it's more visual and still using all the normal command line commands, also for those people who, like me, learned how to program last century.
Okay. Yeah, it's I agree with this statement. It's meant to serve both worlds. We hope to reach the new people in the industry and data science community that are not very familiar with the classical MariaDB client, like some of our senior developers are or senior users. But yeah.
Excellent work. Well, thank you, Robert Bindar in Romania. Looking forward to pip installing and condaing it. Thank you.
Please. Okay. Thank you. Bye.
The next presentation, AMA with Monty. It is Mikael Widenius, the creator of MariaDB, who is inviting you to ask him anything. Welcome, Monty, Mikael Widenius, for the Ask Me Anything session.
Thank you. I'm looking forward to it.
Well, so am I. I have a couple of tricky questions for you. Lots of good questions here coming. We're monitoring the Zulip chat for further questions, so we reserve a bit at the end for the new ones, but I've already grouped the questions here into strategic questions and political questions and hardware questions and development questions. And I can tell the viewers I have not prepared Monty. We'll get the best more answers from Monty by being very spontaneous. So the first question, how do you feel, Monty?
Feeling good. I think the conference is doing great. I was really happy with Peter Zaitsev. He was doing good.
So what do you expect? I won't ask you what do you expect people to ask. Instead, I will pick the first question by somebody whom you know. You've met him in Albania, Tirana, 2005, Erwin Rucci. He's asking, is making MariaDB the fastest database your first priority?
Let's say you can never be fastest in everything, but I do have a sweet spot for performance, and I like to get the most out of the machine. So everything we do, or especially what I do, is regarding to do the best you can with little resources. And I'm happy to see that MySQL 6.0, actually, sorry, not MySQL 6.0, MariaDB 10.6 is about performance. So right. We have the whole team doing mostly performance things that should have been fixed a long time ago, or kind of just been forgotten. So I expect a lot of new interesting things.
A bit because your questions need to be fairly short because we have so many exciting questions. The second question here is an evergreen that I suppose you've answered many times before. How do you compare MariaDB with Postgres in one sentence?
I think they're both great databases, and it depends on your usage. If you're going to use a cluster setup, then I think that MariaDB is the better choice. We have more experience in that. If you are just using, have an extensible database and you have programmers and you want to do extensions, then Postgres is more suitable for that.
So then a question on the differences between MariaDB and MySQL. So MariaDB is innovating a lot, and sometimes this is from Abbas, is asking that it feels like they are becoming different products altogether when comparing Oracle MySQL, Performance Server, Maria. He believes that features like dynamic columns and JSON type support and InnoDB ExtraDB should be available in all three. What's your take on that?
I think that we are more following the model that we had from MySQL time, where we trying to do stable releases and do maintain most of those, and something that is suitable for community to be part of. MySQL is not doing that. I think from the developed model is totally different. And from there also follows that the feature set that we add will be different.
So a follow-up question from Abbas was, do you think that a free non-BSL version, this is not related to MariaDB Foundation, but it's Ask Me Anything, so anyway, I will ask you, is such a version of MariaDB max scale, will it be made available for binlog use cases?
I mean, what we are doing, have promised, is that all the releases with all features will be available to the community after a certain time. And that's the whole idea with the BSL. So everything that is max scale is now will be sooner or later available to the community.
Then we have another tricky political question. So Heinz is asking, what is the difference between the MariaDB Foundation and the MariaDB Corporation?
So the foundation is engineered to satisfy users and developers, especially people who want to do commit and help participate in developing MariaDB. And we also take charge of the code in the sense that we guarantee it is always free. The corporation, on the other hand, handles customers and requests where there has to be a timely answer and help when needed.
So what does that mean from a development perspective?
From a development perspective, the corporation has most of the developers in the MariaDB ecosystem, and they are paying those and driving development. While from the foundation, we have mostly handling pull requests from users, but we're also doing development on things that affects a big part of the user base, and also taking patches from including Percona, MySQL, and the whole community. So we take over the maintenance of those patches when they get into the server.
And what does it mean from a customer perspective?
From a customer perspective, it means that you get the best of both worlds. You get open source development from a big community, and you have a vendor who can satisfy all your commercial needs and support needs.
So there, the presentation prior to yours was from Peter Zaitsev, and he had an observation that he found it interesting that when you download MariaDB Server from mariadb.org, after the download, you end up with a page from mariadb.com. What's your comment on that?
Yeah, we are trying to be nice within the MariaDB ecosystem, and the corporation provides both support both for the community and customers, and also the knowledge base and everything else. And they provide a lot of extra information that is useful for people who download MariaDB. So we made an agreement that they can maintain that and take that away from the hands from the foundation. I mean, there's no forced registration or anything.
Then Vincent is asking, what's being done to address the outstanding multi-year long bug reports, not long bug reports, but year-long bug reports for MariaDB, especially true for bugs that cause crashes or data corruption?
Let's say everything that is a crash with data corruption should have a ticket information that says that this is a major and it has to be fixed in the next release. So there shouldn't be any crashing bugs, at least not something that affects a notable part of the user base. There's always corner cases, but not corner cases should also always be fixed in the next release. So there's other feature requests that are not critical. They can be in the knowledge base, not knowledge base, but in the Jira quite long until somebody sees a need that get this fixed or added.
Okay, I still have some strategic questions left, but I also have a limited amount of time to ask you. So I'm jumping now to some technical questions. So James is asking, what feature of MariaDB are you the most proud of?
I'm actually most proud of something that's not many people think is interesting. That we actually take good care of our user base. we care about that upgrades are easy. You can take any MariaDB version and upgrade to the latest one or anything in between directly without doing something. And that means that you need to take a good handling of both storage, the protocol, and everything else, ensure compatibility. You can also take any old MySQL or MariaDB client and it will work unchanged to MariaDB. This is just so that you have no pain. I hate upgrade with passion because every time I upgrade my laptop, something breaks. And I'm trying to do my best to ensure that that doesn't happen with MariaDB. When it comes to features, I think that the replications features we have S3, the online alter table that's a new in MariaDB. They are all exciting, but it's much harder to say which feature is the most exciting one. All developers are looking most closely to what they are coding themselves.
That came from the heart. So now Dion is asking, every piece of software, this is a fun question, so you can relax. Every piece of software can be made to do something it is not designed for. Often when there's something far simpler and more suited to the purpose. So what's the single most ridiculous thing you've seen MariaDB being used for that it really just should not be used for?
I mean, MariaDB is kind of designed for being something that can easily access from the web. But I have horror stories from the old times before MariaDB and my MySQL, where people were just misusing my products. But with the databases, if you try to store the wrong kind of information that is not designed for, then it's a bad thing. But I don't have any real horror stories of that. I'm more about real horror stories of the wrong uses of databases when we go to customers and when they complain about things work perfectly 1 year ago and no things are so slow. And you still today find that they don't have a single index. It's kind of incredible that MariaDB works even in those cases.
So now we're getting more technical. Hamza says that currently JSON as a data type is just an alias for long text when in MySQL, when would the MySQL-like JSON table be planned?
According to the SQL standard, JSON is text, and we are trying to follow the standard. And MySQL did something different for performance reasons, but our JSON is as fast or faster than MySQL, so we kind of proved that that was not needed. And so we are trying to follow the standard, and the only thing that is missing or big thing that is missing in MariaDB 10.5 is JSON table. We almost had it ready, but it didn't make the deadline for the release. So that will be in 10.6.
So how do you compare using JSON functions on the JSON data type with dynamic column functions on a blob data type?
Basically, it's more or less the same as long as you have one simple row. Basically, dynamic columns is there to say that you can have any amount of columns, not arrays or arrays, but just that. And that's the most common things. The benefit of dynamic columns is that every column is typed. So you know that when you put in a date, you get out the date and you can know it's a date. And that's one of the problems with JSON. You have no difference between dates, string, booleans, or anything else. So if you want to have typed and ensure that you don't get dates that is 32nd of December, you should use dynamic columns.
Mm-hmm. So I have two community questions. So for people who learn and use MariaDB, what guidelines do you have to provide to help learning the source code if you want to become a contributor? How should one behave?
To learn the source code is basically you take a problem and try to solve it, and then you dig into it. And we have tutorials in the knowledge base of how to do that. But when you get a stumbling block, you shouldn't just sit there and trying to solve everything yourself. You should go to the free node or preferably Zulip and connect directly with the developers of MariaDB. who can give you hints. And that's the best way to learn. You can also use the email list to ask questions about how does this work and everything else. And especially the foundation, one of the purpose of it is to help newbies. So you can contact the foundation, and if you don't think that we have doing a good job through Zulip or other things, then tell us, and we will try to improve.
Mm-hmm.
But doing a pull request is the easiest way to get your code in. But the problem is, as you said, what should you do before you can do that? And then you have to use one of the channels.
Good. Okay, so then I have a fairly open-ended community question. What can I do to help you? So I don't really know whether this is a person who wants to code or write documentation, but if there's a developer who wishes to help with MariaDB Server, what's the type of help that we need?
I mean, you can help either with documentation, or you can spread the news about our fantastic MariaDB Foundation Fest and tell everybody about it. You can add help adding links to MariaDB Foundation and the project. But the best way is just to be active. Go to the email list or Zulip or Freenode and help other users. And you get much credit within the community when you're doing that. We can help both the project and also yourself when you want to get a job somewhere in the database environment.
Right. So,
and the last thing is that if you want to do the development in the knowledge base, we have a link for easy to solve issues, especially for newbies. Take one of those.
Mm-hmm. So then I got commercial questions. They are not really related to MariaDB Foundation, but hey, we said, ask me anything. So Joel is asking, could you tell us about the high growth of MariaDB in the Latin American market? Have you been to the Latin American market, and what's your take?
Personally, I'm not part of the group who handles customers relationship in that market. But in Latin America, I have been attending MariaDB conferences during this wonderful time when you could still travel. I was been in Peru, Brazil, Argentina, and so on. So I really enjoy being in Latin America, and I would love to start going again when things start to open up. And yeah, but I know when I'm there, there's lots of MariaDB users, but I don't know how many commercial ones.
So the second and last commercial question here is by Santinesh. He's saying, is MariaDB working on some enterprise monitoring tool? And I hope you can say anything about monitoring tools that you know that will be interesting.
Yeah, so we did have some presentation about SkySQL, which is the in the cloud offering of MariaDB, and the corporation are creating monitoring tools within that environment as a complement to our proxy. So that's kind of coming, and I don't know if the license of that eventually. Currently, you can try them out in the SkySQL cloud. Hopefully, we'll have them under BSL. At least that's my hope.
Okay, then two hardware questions here. Richard is asking, have you started to experiment with ARM server builds yet?
So we have ARM in our build bot. So every single push we do is tested on ARM. So from stability point of view, yes. From performance view, we haven't done any specific optimization for ARM yet. And for that, we need somebody to work with the MariaDB Foundation to make that happen, or the corporation.
So Samuel is asking, what's the plan with NVRAM?
So we already have some patches for NVRAM, in other words, persistent memory. And what we have now is that we can store part of or the whole of the InnoDB redo logs in there, which gives you quite a big boost in performance. And we are planning to do much more. But the question is that when will SSD truly replace hard disks and when will NVRAM truly replace SSDs. We are trying to work with all vendors to ensure that whatever you are using, you will get the best performance that is possible with the database. As I said earlier, perfect performance is a passion, and I want to use the latest hardware to achieve that.
Mm-hmm. So one more technical question, and then I will go to a fun question. So John is asking about time series databases. Specialized time series database systems are all the rage, he says. How should one use MariaDB to store and query large-scale time series with billions of time series points in a table?
First, let's take it the black and or helicopter view. A time series database is one normal SQL table that has one index less. That's it. So the only thing that you really win with the time series database is that the retrieval on time is faster because everything is sorted according to time. But with modern hardware, how often do you decide which database to use based if you have one index more or less? So I would say that a lot of the hype about time series databases is just that, hype. If you want to run with petabytes of data, we have column store who can handle that. It doesn't need time series because it internally does some of the same optimization that you would do in a time series database. So it automatically notices that in this block, we only have data for this time series. So we only examine that block. So you get the same benefit with column store as you get from a time series database in most of the cases. And column store is totally open source and free, which is not the case for many of the other time series databases.
Mm-hmm. So on that note, I'll still ask a follow-up question because you mentioned column store. So what are the new features that you're most proud of or that you want to highlight in the latest MariaDB version?
Regarding column store?
Well, regarding the latest MariaDB version, it may be column store if you wish to say that, or it may be something else.
In 10.5, we were more concentrating on ensuring stability and fixing things than adding a lot of new features. But the two main features that is totally new is the S3 engine and the column store engine. So those are something that people probably have not tried out, especially not in earlier MariaDB versions, and they definitely should look up on those because they can greatly change how your operations are working.
So then for the fun question, how the sea lion of MariaDB, it doesn't have a name, does it?
No, it's poor, nameless little creature.
Do
you have a suggestion?
Yeah, I was going to ask, what do you plan to do about that?
In the MySQL time, we had the same problem with a little poor orphan dolphin. And we reached out to the community and asked, is there something you can suggest? And I think that we should do the same thing with the poor little sea lion.
Okay, and the suggestion, it should be a suggestion of the name, but should the suggestion contain something else than just the name?
I think that the best part of the MySQL Dolphin contest was that we got lots of really good names and explanation for why this name. And that was really, really funny and helpful. And that actually helped us choose Sakila. So I really would like to suggest that people who want to participate don't only come up with a good name, come also up with a short story, why and how the sea lion got that name.
So we will set up such a competition, such a game for people to suggest a name and the reason for why that is the right name. We will come up also with a deadline. We're talking internally about that at this point in time. But how do you then plan to select the right name for the MariaDB sea lion?
I have a perfect candidate for judge who knows more about Maria than anybody else, and that's Maria, my daughter.
That's a good suggestion. So let us set up a competition for picking a name for the MariaDB Sea Lion. It has to have a name, and the name has to have a good reasoning, and it will then be picked out by the person named Maria Widenius, your daughter.
Yep.
So any conclusion?
And I think that, as probably people know, this channel is that Maria and also me are both artists. They do great things, and I think that the one who suggests the best name should get a picture from both of them.
That sounds like a great suggestion that I think we can implement. So, any concluding words? Was there a question that you had expected to get that you did not get?
Not really. I'm here with a totally free mind.
So, any concluding words? Any wishes for the users that you wish to tell them?
Yes, please tell them that we are still continuing this fest the whole week. If you have people in China or Asia, please tell them that this is excellent time to join and get more information. And please spread the news about MariaDB to everybody you know. So, and about the foundation to all your developers, so we can continue the work that we are doing.
Right. So tomorrow, or still later on today, we will continue in New York. Tomorrow is the third and last day of New York. Today is the last day of Paris. And as you say, on Friday, Saturday, Sunday, we'll do Singapore and Beijing. So that's the end of the first MariaDB Server Fest that we're having this week. So with those words, thank you, Monty. Thank you, Mikael Widenius, for the Ask Me Anything session.
Thank you.
The next presentation, Sasha Vanyachin, building a relational data lake with MariaDB Column Store.
Hello. I am presenting on behalf of Virtual Health, a growing startup that provides software as a service to healthcare insurance companies. But the problem we are presenting is not specific to healthcare. In many applications, transactional data became less relevant to daily operations with age. In contrast, as historical volumes grow, the data became more valuable for analytics. Here, we describe the relational data lake approach for storing daily, read-only snapshots of transactional databases. To lower the costs, we chose MariaDB Column Store because of its inherent data compression and Amazon Web Services S3 storage support. 10 years ago, James Dixon, founder and former CTO of Pentaho, came up with the data lake concept. A crucial data lake aspect is retaining the source data in its original form and format. I will elaborate more on the importance of this particular aspect later in the slides. Another problem we're addressing here is not unique to virtual health. Operational systems in healthcare are complex and not directly suitable for analytics or machine learning algorithms. We chose to build the data pipeline to MariaDB Column Store since it already provides open source examples of integration with Jupyter Notebooks and Apache Zeppelin, popular open source tools used for data exploration and analytics. We present our data pipeline and share tips and tricks we have learned in the process. To conclude the introduction, I remind of a known problem of running analytical queries on the transactional database that can be slow and painful. To address this problem, a special storage format, columnar, can significantly improve performance of analytical queries. In this talk, we will focus on the MariaDB column store. We will show some representative use cases and demonstrate how MariaDB column store can be used for typical analytical queries. Why some queries are slow in transactional databases? Let us find top 10 clients who visited doctors most often. Such ranking queries are known to be hard for relational database technologies. Thus, it is not surprising that this query is so slow. As a side note, please take a look at the locations column highlighted on this slide. Why we are so interested in visit locations? This is just one example how our software reduces healthcare costs by enabling booking multiple doctor's appointments in one location. Coming back to the query speedup. What about indexing? But this query is already using index, as shown on the query explained plan. What about additional index? Indeed, adding covered index does help. But the query is still slow, particularly for user interface, when users tend to reload the web page when the query is so slow, which in turn overloads the database with repeated slow queries. But the first ranking query example was only the beginning. How about the second ranking query? Identifying high-value clients. Please note that multiple table joins are not uncommon when the schema is highly normalized for transactional performance. You must be truly patient to get the result. It took over 9 hours to learn that some clients experienced the most expensive treatment. As a homework, you may do your own web search to learn more about it. Let me summarize why our analytical queries were slow in the transactional environment. This is because most relational databases, such as MariaDB, are row-oriented. If query needs 2 columns, it will read the whole row. InnoDB organizes tables by pages, resulting in even more data to be read in. And the last but not least, MariaDB will use only one CPU core per query. In case of our first ranking query, the row-oriented database have to read the whole row to get the data for just 3 columns, as shown on this slide. In contrast, the column-oriented databases read only the data from the 3 columns involved in the query. Now let me present the results of our comparison of the InnoDB versus column store. The comparison was done using 2 different EC2 instances, small and very large. And let me describe here our first tip regarding the column store that happens to have 2 installation options. The single node, not distributed option is useful for initial evaluation, but it is not expandable, which is often overlooked. This explains why we started with the distributed installation on the single node, which may look confusing, but is unavoidable if you plan to add more nodes in the future. What about the first ranking query? There is no large difference, since the added covered index is essentially an equivalent of the column store, reading data from just 3 columns. However, our conclusion is that the column store is preferable, since you cannot add covered indices for all of your analytical queries. What about the very large query? Let us find out. Well, this query is indeed challenging. The extra tuning is necessary. The solution is to allow the disk-based joins. After the column store restart, we are ready to try again, and wow! Even with disk-based joins, the column store performance is more than 2 orders of magnitude faster. The performance can be improved further when the joins fit in memory. Another column store benefit is a reduced storage. In our case, we observed an overall factor of 4. Half of that is due to a compression. We have a lot of binary encrypted protected health information data that are not expected to compress well. And another half is from indices removal. For the lack of time, I refer to other column store presentations to learn about this feature in more details. With such an impressive performance gain, we clearly need to transfer data to the column store. But how? What about the traditional extract, transform, and load approach? Since MariaDB column store has a built-in transactional engine, we use an asynchronous replication slave as our data staging area. As I said before, the crucial data lake aspect is to minimize data transformation to retain its original format. For data load, we take advantage of 2 built-in InnoDB and column store engines and use a simple but elegant approach. Stop replication, load data using in parallel the internal, very efficient binary data transfer, then resume the replication. In our approach, we essentially implemented the so-called ELT, not the traditional ETL. This is in line with the general shift towards ELT. The shift is enabled by an increased computing power and capabilities provided by the cloud. In practice, one must transfer the database schema as a first step. In a first approximation, it is rather simple. You just replace engine InnoDB with column store. However, this doesn't work out of the box. These slides list certain steps you need to take to eliminate DDL differences, such as the absence of explicit indices in the column store. Also, some data types are not supported. We used the replacements listed on this slide. Here are some other differences that we encountered. Some of these are legacy and not needed in the original schema. Also, virtual columns are not supported. We expect that since virtual columns has no additional data, they can simply be omitted. But those differences were rather trivial. Here we need to dive deeper as it relates to subtle differences in the known issue with null values versus empty strings for certain string data types. As documented, implicit value for string types is an empty string. Here we are converting the schema to column store as is. But then, as documented, the column store treats a zero-length string as a null value. As a result of these features, during data transfer, you will get an error, as shown on the slide. To resolve this issue, more schema tweaking is needed. You may need to remove not null for columns for all strings data types. As you may expect, the list of reserved words is different, which creates some extra issues. For those schemas that have the table user, like in MySQL user, a recent example of such schema was presented at the MariaDB webinar. As we iterated over the schema conversion, we found that Docker images are very helpful in this process. Now, to the most advanced part of the presentation, data import. Here are more technical details about the approach. As documented, it is using very efficient binary data transfers behind the scenes. In certain cases, you may need to execute such command lines yourself, as we described in the next slides. This is because the internal approach may not work for you, as it provides no interface to control the separator, such as in cases of data having the backslash character. To debug such failures, please take a look at the error files generated in your data directory. For those cases, we used the command line as described on the slide. Also, we had to switch to the command line to increase the read buffer, as shown on this slide. Here is another case to use the command line to preserve the original data values, since by default the column store will replace null values with zeros for the nullable integer or date and time columns. Also, for the very large tables, you may encounter the error shown on the slide. In that case, you just need to tune configuration further as described. Fortunately, this could be done online. And the last but not least advice is to disable the binary login during data transfer. Otherwise, you would accumulate huge binary log volumes during data import. To conclude, let me clarify first that on the numerous issues we described in our previous slides, please do not get the wrong impression that column store is some kind of an emerging product with associated issues. On the contrary, the successful load of healthcare data to the column store is attesting to its level of maturity. The healthcare records are notoriously complex. You may get a preview of this complexity by looking at a couple of open source electronic health record projects that have about 200 tables each. The virtual health database schema is on par with more comprehensive commercial electronic health record systems that have 3 times as much more tables and thousands of columns. Summarizing, let me conclude that the relational data lake built with MariaDB column store retains the source data in their original format. We observed analytical query speedup of more than 2 orders of magnitude, and the native MariaDB protocol lowers application integration barriers. Thus, we look forward to evaluate the latest MariaDB community server version that includes the column store plugin with S3 storage support. Also, the data lake approach looks attractive for data archival. Here, data lake retention of the original schema simplifies application data access. Thank you for your attention. Any questions?
Sasha Vanyashin in Raleigh, North Carolina. Welcome. Great talk.
Thank you. Thank you for having me.
Our pleasure. So I'll start with a simple question. Why, like I often do in these Q&A sessions, why did you pick MariaDB column store?
Well, we earlier evaluated another open source database called ClickHouse. For some benchmarks, ClickHouse was faster and provided better compression. However, we have some concerns regarding ClickHouse MySQL client compatibility. And since we are planning also to integrate our application front end with MariaDB column store, we chose the column store because it's an integrated solution.
Mm-hmm. So being in the same product provided the advantages for you. So when I'm looking at both column store in general and your presentation, I get a bit confused by the version numbering. There's this 10.3, 10.4, 10.5 that we know from MariaDB Server, and then you talk about 1.2.5 and 1.5. So can you say something about these version numbering? Which version should I be looking for, and how do I find myself correctly in the correct numbering system?
Yes, it's a bit confusing for historical reasons because the column store has not been so tightly integrated in the past and had a different versioning numbering, which is now simply became a different versioning for the engine. It's like InnoDB has its own engine versions, like now the column store. So this talk is presenting results done with the latest general availability column store release, which is 1.2.5 as written in the slides, which corresponds to MariaDB 10.3.16, which is far behind with the latest and the greatest release with many more features, 10.5, which also includes the very much refactored column store engine 1.5. So that's where we are now. So it's not that difficult to follow.
Okay, yes, and we heard in another presentation here at the MariaDB Server Fest by Sergey Golubchik that these maturity stages are independent of each other. So you were saying now that 1.2.5 is the latest GA version, and that 1.5 is not yet fully GA, and 1.5 is part of the MariaDB 10.5, which in itself is generally available, but the column store is a plugin and it's independently regarded when it comes to maturity. So what you can expect then, if I understand it correctly, is that 10.5, a release of 10.5 MariaDB Server will soon include a stable version of the 1.5 column store. Is that correct?
Yes, we look forward to that.
So how you look forward to it, but have you already tested it? Have you tried kicked the tires on it?
Not yet, and we are in the process of preparing for the upgrade, but because of this big jump in version numbers, it presents a kind of steep learning barrier, because, for example, the control commands that I kind of provided in my presentation in many places, they are completely reworked and have different names. So it requires more time to prepare for an upgrade.
Then you mentioned this slave replication, MariaDB slave replication. So you're not using the built-in slave replication from InnoDB to column store, but why?
Well, thank you for bringing this feature into discussion. It's a relatively recent feature. Previously, it has not been available. However, there are two considerations that have to be taken into account. One is that the whole idea of the data lake or a data warehousing is to preserve a fixed snapshot of data taken at a certain time. Besides that, the column store engine has highly efficient and also parallel batch data processing, which we understand that the slave replication does not batch updates. So it should work very well for the tables that we typically have plenty of those that are slowly changing, like configurations, dictionaries, and such. For those, there is indeed there are no need to do this select, insert to populate. It could be just a live replica as it is. But for the highly kind of active transactional tables with millions of updates per day, it's not a best solution.
So what about other plugins in MariaDB, like the audit plugin? Does it work properly with the column store?
Yes, we essentially are very pleased that we tested the audit plugin and it works out of the box as documented, and we have to use it when the column store will be deployed for data archival, keeping the actual patient protected health information data. Then audit plugin is a must.
In the presentation, I seem to notice something about the large index. Why is it so large? And is there something that you can, the covered index, or what was its name? What is it and how can it be reduced?
Oh, good catch. That's essentially, it can be seen at the slides about trying to improve the slow query in the InnoDB world. Indeed, the very large index size is a side effect of not fully normalized locations address. If we refactor the schema separating location addresses in a dedicated table, then the combined index will become much smaller and just using the location ID. But this is just an example that you have to kind of, for every analytics query, you need to totally refactor your schema, optimize for transaction. That is simply doesn't scale. So that's why the column store with, so to speak, built-in indexing is the best solution.
Okay. Any other experiences that you wish to highlight, either based on what you got asked on Zulip or other things that you want to highlight from your presentation?
Oh, yes, we just got a comment, not a question, from Hari, who wrote that he thinks one good thing is that the row store and column store are compatibly provided by one company, MariaDB. And I fully support and willing to promote that message. We all in analytics world benefit greatly from this kind of ready-to-use hybrid transactional and analytical processing in one package, and we look forward to further developments in that area.
Great. HTAP, hybrid transactional and analytical processing. Those were really good concluding words, Sasha Vanyashin. Thank you. Our next presenter is Shiv Iyer, Migration Tales.
I'm Shiv. I'm Shiv Iyer, founder and principal of MariaDB. So I just want to talk quickly about me. I'm an open source database systems operations geek, and also the founder of MariaDB, with core focus, interests, and performance, scalability, high availability, and data SRE. Over 18 years, I'm in open source database systems, work for some of the best companies, starting with MySQL Sun. Mostly I was working from Asia Pacific and Southeast Asian offices of Sun. Worked as a data SRE for PayPal, eBay, AOL, National Geographic, Pinterest, Yahoo Japan, Percona, and PalaminoDB. Currently, I'm the founder and principal, as I said, with over 350 customers worldwide. Most of them are internet properties. 90% of our customers are internet properties. So that means the rest of the 10% are ISVs. And that really has some connections to today's talk. Migration talks. MariaDB migration talks. So most of that started as curious conversations with some of the independent software vendors who are into the business of providing software infrastructure for banking, financial services, insurance, and also connected devices for healthcare business. Interestingly, both of them carry a lot of sensitive private data. So when they started talking to us, like they started conversation like, hey, we need an alternative for Oracle, open source free software for Oracle, and we can see you guys provide support and services for open source database systems. Interestingly, we provide the same what our then prospective customers was interested about, MySQL and MariaDB. The conversation started. The biggest question for us was like the privacy and security, or then a question, it was like biggest concern. And the conversation started like, hey, we're happy that we're getting a community supported open source free software database systems infrastructure, but then what about the privacy and security? So every day, every meeting we had, there was a conversation on privacy. So I'll talk about that in detail. Of course, performance rules the transaction processing system, data processing systems. Scale, most of the banking, most of the health tech companies have now their consumer-facing internet applications on mobile devices, or maybe even on the wearables. So scale was definitely a big thing. The transaction should be reliable because sensitive data, which is governed by both the law of the land and other industry compliance standard. The biggest concern started at some phase of our conversation, which was also during most of the conversation, was like the complexities in open source licensing. Some texts were even not clear for the corporate lawyers, so we even had an opportunity to sit with some of the lawyers and read the licensing norms. GPL was quite easy for everyone to understand. There was nothing missing between the lines, or something was gray between the lines. So GPL was good. BSD open source licensing was the one, but luckily we weren't talking PostgreSQL then. The cost of maintenance operations, like this was, I talk about this in our slides, other slides, but then maintenance operations, licensing complexity, privacy and security were the leading topics of our conversation. So what was so exciting about migrating to MariaDB? One, we are a big MariaDB fan company. Most of our engineers, most of our consultants are from MySQL AV, from MariaDB, or they supported MariaDB or MySQL for some of the largest internal properties. Open source, free, and community-powered project was really a big point of our interest. And again, the Oracle, they were all Oracle customers. They are all completely an Oracle shop. Their entire application was built on Oracle. So definitely they were looking for how we can have another database system which is 80 to 85% compatibility, or the feature rich like Oracle, and how we can evaluate. And so the conversation was always in that direction, like, hey, licensing complexities, the cost of ownership of license, and the investments on the infrastructure for building an Oracle-powered database application. And interestingly, very interestingly, the DBAs bank story evolved somewhere close to that time period. So MariaDB support DBAs, and that story was used several times. Hey, look, there is a bank in Asia Pacific, Southeast Asian markets. They are on MariaDB. Also, there are a lot of internet scale data infrastructure, like Google, Red Hat, Wiki, Nokia, and several of our customers to be at least close to this volume. So we used to show them, hey, something, we process approximately 300 billion ad impression for one of the largest ad networks in the world. Very write intensive, completely on MariaDB, and it works great. So yeah, a lot of production level benchmarks and the matrices we shared, so that they get some idea, like, we are talking something sensible. As we increased our frequency of conversation, the topic was always like, hey, how much I have visibility to the database performance matrices? What are the native tools provided, supported by MariaDB to give us visibility to troubleshoot more efficiently? Definitely, there was no compromise on the reliability, and the availability was one of the key areas. Like, so the system should be capable of a redundant database infrastructure. There should not be any single point of failure. There should be a MariaDB aware load balancer in place, which takes care of the failover. Like I said, there was no scope for data loss. It's a financial institution which also support several healthcare providers. That means they provide insurance, they provide they have an extended connections with the systems which takes care of the several sensitive healthcare sensitive databases. Support was always a conversation topic. Every time when we tell like, hey, you know something, we can build a highly reliable, fault-tolerant, self-healing system on top of MariaDB. The first question is like, hey, are you sure that this scale of infrastructure we get people to support? So yes. So it was a good time actually. Like we talked to business, we talked to the community people, but it was a very interesting phase. Capacity planning and sizing. So when I used to talk to my customer who always 30%, 40% made up their interest, that he knows something. When I say 30, 40%, it's like our frequency started increasing, frequency of meetings started increasing. Like it used to be like twice a month, it started becoming once a week. Then it's moved to a phase that every second day we'll have a conversation about, are we going to use the same capacity for this MariaDB infrastructure? Do we need to oversize it or undersize it? How is going to be the efficiency, performance and storage efficiency on SSDs, and how we can tune to make MariaDB even faster. And most important, what I have seen gone wrong terribly on MariaDB. So we were very honest, like there are good stories or bad stories. So I talk about this, but this was our checklist of choosing MariaDB, or like this is a business checklist. This is a checklist which has been which evolved after several meetings with the customer. Enterprise class database infrastructure. That means like data reliability for web scale. So when I say data, right, there's a lot of differences with the customers we have worked in the past with working with the financial institutions. We work with the ad tech companies. We work with gaming companies. We work with some of the SaaS. There are really traffic intensive. Some of the biggest e-commerce companies. They're really big in traffic. But when it comes to transaction sensitivity, right, or transaction durability, reliability, demand, the financial institution and that includes core banking, insurances, and also the healthcare software companies with whom we used to work. It looks very heavy, at least for us who come from an internet data infrastructure operations background. So data reliability for web scale, performance, always the demand was like how many number of transactions we can process if we scale our business from X to 5X. Scaling horizontally. Hey, this is something very interesting. Like Oracle don't have a horizontal scalable solutions, right? They talk something called real application cluster. I'm not a serious Oracle guy. I read a lot of Oracle books. This purely out of my technical interest, but I don't work on any production Oracle system. So when I was looking at like, hey, you talk on most of the meeting you talk about scalability. How do you work on it? Somewhat of I understood that when they say scalability, it's about shared everything architecture, scalability, which something what Oracle call as Oracle real application clusters. But in the world of MariaDB, we have something called shared nothing architecture. And trust me, I took one complete week to finalize, or then a finalizing it is like one complete week to create a document which talks about how shared everything works, how shared nothing works for the business team, and communicate, convince, and finalize on how shared nothing architecture works great for a web scale and cost efficiently. Fault tolerance system should be available all the time. Fintech companies, So most of them were graduating from a bank to a fintech company. So highly reliable system. Data privacy security, very important. Synchronous and semi-synchronous replication was one of the key topics. Reason because when we say there is no scope for single point of failure, that means that in a distributed redundant system, what could be the worst thing can happen is if there is a database instance crash or primary database instance crash, what's going to be the data loss impact on the business? Pretty high, seriously pretty high. During the key business hours, very, very high. The numbers were quite shocking for us. We never thought okay, what happens if a banking system goes down by 5 minutes or 10 minutes? The numbers are too big, really big. So there have been always some. So when we go for some meetings, it's being wow, the MariaDB is great. This is good. This is something which takes care of our data of the future, right? Data infrastructure of the future. When we go for other meetings, we can't compromise on data loss. Data loss means the loss for the business, plus there'll be a lot of statutory guidelines which could make severe impact on the professional career of the senior executives of the bank. There was no scope for that, and we need to really spend a lot of time in making them understand how MariaDB replication addresses the synchronous replication with Galera cluster works to make sure that it's everything or nothing. There is the transaction either get completed or get rolled back in a distributed system. Point in time recovery, yes. Audit, transaction audit. That is completely on the statutory guidelines. Columnar stores for data analytics. So there have been hey, we use Oracle, we use Exadata. That's an appliance of Oracle that works great for analytics. We use something like Exalytics or something, a lot of things. So the idea was Oracle is a single vendor for me. For now, for database infrastructure. Now, when I move to MariaDB, is it something I'm going to have multiple vendors? Answer was in MariaDB, we have definitely the infrastructure to power your different varieties of SQLs, different variety of queries, transaction queries are taken very well, gracefully by storage engine built for asset compliance systems. If you're looking for analytics, definitely MariaDB solves that. If you're looking at, so we need to explain them. There is a difference between storage engine, which is very MySQL, MariaDB specific systems, or it's a very, very specific to MariaDB or MySQL. Compared to Oracle, we don't have something like a storage engine there. So it's when I used to go for the meetings, I used to hey, here's something we can use InnoDB, we can use Area. Maybe after a day or two, I got a question do you mean to say these are the two different database system stack from MariaDB? I was no, this all be inside single MariaDB. So yeah, how can we troubleshoot more proactively? Systems can behave awry, weird. It's acceptable, but then we should be able to troubleshoot them. So what are the technology infrastructure MariaDB provide to troubleshoot MariaDB even better? Optimal indexing, and how is the indexing MariaDB work different from Oracle or Microsoft SQL Server? Disk I/O performance optimization, partitioning capabilities, and tolerance and partition pruning. Again, every of our conversation, every of our bullets on the meeting will have a HA, high availability, and upgrades and migration. This is the last points in our most of meetings, but then at some point of time it was the cost of upgradation is something very high. The proprietary software, big business because of the licensing complexities. But then open source, what you see is the complexity is what's going to be the the reliability of the new release and what's going to be the responsiveness in the bugs reported and how the workflow work. And so for that conversation, we even pulled out, MariaDB is not just a new company. It's been built by the business, by the team, by the community, who have spent several decades on database systems. So we even started pulling this. Okay, this presentation I have used from CIOs, CTOs of multiple banks and several hospitals with my ISV partners. So I go with my ISV partner. My ISV partner tell like, hey, something, we are coming with a new database system. Some of the banks was like, no, it's okay. So, but then when we say that new database system is from MariaDB, and remember these guys don't have any exposure to open source systems. So we say like, this is built by the people who are database systems geeks. They power Google. They work with Facebook. So they are very, very close with closely associated technically with some of the planet scale internet properties. Founded by Monty, it's a very old team, like started in 1982. The history is like Sunbot, and the core MySQL engineers left Sun for good. Oracle bought Sun and MariaDB Foundation. So this is something very interesting, right? MariaDB, we strongly recommend our customers MariaDB for one big reason. MariaDB Server project is supported by MariaDB Foundation, not for profit, and MariaDB Foundation is never ever going to be owned by a single entity or business or corporation, whatever is that, or a single individual. So it's completely a social innovation powered by a community, and all the repositories are on GitHub. All of the source repositories of MariaDB Server are on GitHub, managed by MariaDB Foundation. So when we reached a very senior, serious level of discussions, like we made one single page for our MariaDB internal engineering team to nail it on our walls, or like we have virtual corporation like MariaDB. So all of us work from home. So all of our offices have this checklist. What we should think about what we should advocate on when we are recommending a production-ready database systems for an enterprise. A strong community committer, because support is the lifeline of the database systems. Bug database transparency, which is human managed, approved, and the visibility to general public. And how do we troubleshoot for performance, for tuning the database systems, and the tools for reliability and archiving, security. So we started writing out like, hey, we need definitely a point-in-time database recovery tool. That's very important. Should power application. We should have load balancer, native load balancers. That means they should be aware of how MariaDB systems work, and what are the future commitments or complexities with open source licensing. So who owns the database? There were several people who were the owners of database. Initially, we thought like our meetings are going to be only with the DBAs, so database architect, or some data SRE or production engineering team. But then it started growing. We started even talking to the CEO. We started even talking to the board. Board was curious about how severe can be impact if there was something goes wrong during the migration, post migration, data theft. Some of the government bodies, they were like, hey, we will have the statutory audit on the transactions, especially on the payment cards, card payment industry, right? Like, we have every quarter we look at all the transactions on the categories what we qualify. That means we need the entire transaction history, the origination, the workflow, and the destination. We need the audit of every of things. So we spoke to them. We worked on the audit matrices, how it looked like. Interestingly, we started realizing that in our data-powered economy, right? What do you call dataonomy today? It is not that the ownership of data is just with the DBA. Technically, it is always DBA the owner of the database system. But then there are different stakeholders. And all these stakeholders look for how data infrastructure can benefit their business. And this included both technical and functional interface and operations, which include like who approves a change in database systems parameters, who decides which matrices are going to be monitored, who approves high availability architecture for database infrastructure. But technically, right, we every of our meetings on the data ops responsibility for MariaDB infrastructure. It's like technically the database infrastructure, MariaDB database infrastructure is going to be a DBA. And please do not get into the pockets of a compulsive automation disorder. Like, automation is great, automate all the repetitive tasks, but then don't get into the phase of automate the task which handles very sensitive information. So don't do that. For example, the alert validation. Please do not automate it. Alerting is great. That's an automatic one. But then who is going to validate or who is going to approve any workflow from there? Is it going to be a false alarm, or if it's going to be something which needs immediate attention? Please do not automate it. So at some point of time, it has been very clear, evident for us and the customer. So we started feeling like, hey, good, whatever time we are spending in this our conversation is going to go good, because the customer functionally agreed to come out of Oracle to MariaDB. That was a big day. So we wanted to make sure that we'll never make things complex. So like 90% of your data types in Oracle are what we have shared now, and these are the alternative for them. And when you do the sizing, we personally sit with you, because we neither we want you to oversize it, causing a very fragmented, underperforming SQL intensive database application, or even undersize it that you have future data operations issues, like the data is too big to get accommodated there. And we found that it really fixes, like because we work continuously with some of the largest internet properties which are generously sized, and over a period of time we say like this generously sized always big is good is definitely not good every time. Our learnings we are playing here, right? We'll be very conservative. We'll not oversize it. We want to approve column by column. We approve it because we want this migration to be successful, and that really helped on our second, third phase, where we are going to get data into the MariaDB. It's quite straightforward. SQL mode Oracle. That is from MariaDB 10.3, which is PL/SQL compatible database system. Sequences, introduction of sequences in MariaDB 10.3 was much weighted, or sequences were like really because most of the Oracle guys are very comfortable using sequences for their database architecture. And so like we have a sequence engine, and it's a distributed as a plugin, and that takes care of your sequence generation, auto generation of unique numbers. Okay, this wasn't to offend anyone, right? I was scared when I made this presentation. I was very scared because I was going and talking about this to people who have been working on Oracle for 15 years or 20 years. But then after making this slide, and when I was in the office for presentation, in my customer's office in presentation, right, I was really scared, like, hey, bye bye Oracle. But then it was good. People are actually happy. They're like, hey, you know something, we are making things for a bigger internet scale presence of our bank or hospital, and it's going to be an open source database system, which means more security, right? So open source is definitely more secure, and the cost was really a driving factor, right? We are not going to spend any more for complicated licensing terms. We had a party for this, I remember, yeah. The data semantics or the transaction semantics, what I mean by that is the structure of transaction handling in Oracle and MariaDB were very close to each other, right? On InnoDB, right? We declare a transaction and we'll have a SQL ME commit. Oracle default isolation level is read committed, and there was always a conversation about how repeatable read is different from read committed. So, but there is a differentiation factor we built during our entire conversation of this upgrade. Look, we should be aware about how Oracle's internals work, like, you know, where you have multiple memory structures and background processes which talks to data files. Whereas in MariaDB, it's like you have schema objects are owned by several databases. The schema objects are nothing but the tables, indexes, views, and the physical structure of these logical schema entities are your database files, InnoDB database files. We were using InnoDB in most of the conversation because Oracle to InnoDB closely related. Both are transaction-oriented systems, right? Engine is InnoDB. Oracle is a transaction processing system. Yeah. So this is like quite clear, right? You know, like we wanted a system which is ACID compliant, built for sort search, efficient, query performance, full text search support, archiving, data archiving, store complex graph, and cloud ready or cloud efficient. This is like, hey, this one slide would have saved several hours of mine during my meetings. Trust me. When I have this slide, it's solved, right? Hey, in MariaDB, you have storage engines. If you are talking about ACID compliant, strictly ACID compliant transaction processing row-based system, you have InnoDB and ExtraDB. When you're talking about a columnar data store for big database analytics, big data analytics, right? There is MariaDB columns too. So please do not move the data across storage engine unless you are really confident about it. So this was one, most of our meetings on storage engine choice. I used to tell this. Choose the storage engine best fitted for you. So if you're looking at something, a log structured merge tree storage engine for storage efficiency and write performance, definitely MyRocks. But then MyRocks, which is RocksDB as a storage engine, is not to supplement InnoDB. Or none of the storage engines are there to supplement each other. They are all going to complement each other. When used appropriately, they all form a very robust ecosystem for data ops, data handling. Archiving to cloud, S3 storage engine. It was very new. By the way, S3 we never got a chance to talk till recently. So when we're talking about observability and visibility to the database infrastructure, we're going to be very clear. Like one, we want to have SQLs monitored by response time. SQLs purely monitored by latency response time, not on throughput, not on the resource usage consumption, and the efficiency of database objects, like which means more focus to index performance, the indexes which are used, redundant, and missing. can we troubleshoot the query performance by looking at these matrices? This is like, so because in Oracle they have always like, so every of a meeting like, hey Shiv, you know something? In Oracle this works like that. How does it work in MariaDB? So I was like, okay, I was making a feature list of Oracle, what they use, a detailed feature list of MariaDB, what we continuously do research in MariaDB. So the effort was be a proactive sizing and build a proactive team engaged in infrastructure sizing and capacity planning. And how do we validate the availability, or how do we validate the database performance and reliability? So how we can have custom alerting and notification system with integrated workflow to make sure that database infrastructure on MariaDB is going to be reliable. So in Oracle, they talk about, hey, you know something? We have a lot of trace files. We have a lot of statistics packs generated files, a lot of files to troubleshoot. So I was like, okay, what we used to tell to them was like, there is nothing short in MariaDB ecosystem. If you want to troubleshoot MariaDB using logs, you get a lot. Use them very carefully. Only use them carefully. You get a lot of information. Slow query log, good if you're like. The most recommended one if you want to troubleshoot the query performance faster. If you want to find out like the queries by latency and top 5 queries by latency, which is impacting database performance by 70% or 80%. If you want to make a list of it, retain it, spend time on it, it's worth, because you improve performance by that X%, like 70%, 80% by tuning 6-7 queries. It's a good exercise. Sorry. Error log, it's good, really good if you want to report MariaDB bugs or any critical errors. General log, you get everything, but you want to be very transparent. There is always, not just in this log, most of our conversation we want to be transparent with this customer, like any customer. There are always some good and bad of everything. General log is going to be resource intensive. You want it, you're going to spend a lot for the storage. And for the compliance and regulatory audits, we strongly recommend audit log, and that really worked. That is quite exciting for them. Like, something we have on our open source database system built for the data privacy and security concerns. Or if so. Let me tell you an interesting, quick story there. When I used to talk to them when I used to talk to my customers on, on troubleshooting performance on MariaDB, on more and more on logs, suddenly one of the DBAs, like in Oracle, it was more easy. We used to have a lot of tables, data dictionary tables, which you get information about. Does that mean that in MariaDB you don't have much data dictionary tables for this? I was like, of course it's there. Of course it's there. There's like fine-tune performance schema, enable performance schema, fine-tune the the variables, and you have access to several data dictionary tables, MariaDB specific data dictionary tables, which you can query and find whatever we're talking about there in the slow query log. You get the same of them or more from the performance schema. So the number of parameters each database systems provide is insane. Like, I'm sorry, I'm just putting this like insane. Like, there's several parameters, very difficult to even remember. Like, it runs in thousands in Oracle. MariaDB is no less too. But then, always what I understood from a customer interest was like, more parameters was more problem, right? How we can have very minimalistic performance tuning parameters for an optimal performance. And definitely, MariaDB is highly tolerant on unlike many of our proprietary database systems, MariaDB is highly tolerant when it comes to tuning the system parameters or system variables. Right? I use the word parameters after talking a lot with Oracle DBs. Yeah, but that's good. Learning is good. So I was like, hey, you don't need to really work on several parameters for a really optimal performance. Less is more most often. Like InnoDB buffer pool size, which is about how much memory you have for InnoDB. Log file size, it's good, but then it's not too big. It's not too good there. It's good to size it optimally. Handling threads, tuning MariaDB thread handling mechanism. The pool of threads on a web scale works optimal, and most of our benchmarks even it work for customer too. Connection handling, and the InnoDB flush log on each and every individual transaction count. So so this is something like, hey, you're looking at a good performance, you can keep it 0 2, but definitely not for a bank or for any business where every transaction means there's a lot of reputation and a lot of money in that. So we are like, hey, we strongly recommend one. It's okay. Sometimes reliability stands more than the performance, and that was good. Like the conversation was always on the best interest of both, right? And both for us and for MariaDB, and definitely for the end customer. So these are the compliance like PCI, GDPR, HIPAA, and medical data access control, data access, privacy, and protection laws, and how we arrest the rogue SQLs. So like I said, right, the compliance was always a big topic of interest, or the very serious topic, like how we make sure that our card processing systems are safe, and how the transactions are audited. Like I said, it's an ISV with a lot of customers across Europe. So how we make sure that GDPR compliance is validated, how the health care data is protected, how we can build an end-to-end encryption on MariaDB. So MariaDB provide data protection for both in transport as well as at rest was really interesting for them. So as the advanced encryption standard for the data at rest and transport layer security algorithms on data in motion gives a clear indication of how we are building or proposing a MariaDB infrastructure which protects the data, right? Which makes sure that data is safe in rest as well as in transport. Data masking and SQL injection blocking SQL injection attempts with MariaDB firewall configure in max scale. Make sure that like your database infrastructure is protected against the face attacks like DOS and DDoS, denial of service, and distributed denial of service. This is like very important, right? There should not be like any data reliability issues when you are building a financial system or a healthcare system. So we found this quite serious focus. This section is completely was talking about it, like how we can use MariaDB proxy to build a very robust transaction the safe and secure transaction processing system with very robust firewall rules. Also, like how we can build a database infrastructure operations on the results set size. Even if someone get in, they can't pull down so much of queries. Like how we can restrict on the result set. So the firewall was purely built. The rule of the firewall was purely built on the areas like the queries from each user is strictly controlled by the duration, the time of the day, the type of the query. Even look, these are all even from the legitimate bank employees or the bank partners. But then not all the queries at all the time of the business is not acceptable. Not all the query type is acceptable. Also, the syntax like there is a common syntax which application the ISV is rolled out as an API to access the data, but then we maintained a strict syntax rule that is approved by the business and integrated at the load balancers like MariaDB max scale to make sure that queries are strictly controlled, orchestrated at a database firewall. So data obfuscation was about, data is always encrypted, safe. So at when you're using InnoDB or ExtraDB, it's like you can encrypt all the tables or even the selected ones. ARIA works good for all the tables, but then you have a prerequisite of page. So when our conversation started close to getting MariaDB in production, 99% of the time the conversation is like InnoDB compatible one, because something as I told before, right? Very close to Oracle, right? So it's just like InnoDB, and we've been upfront, right? All these the data encryption, data security, there are exceptions actually, right? The log files are exempted, which include audit logs, low-query log, error log, general log. So that means that you need to work hard. There are definitely threat areas, but then it's been notified in advance. MariaDB audit plugin records everything, which includes the host username, the queries accessed, queries executed, and the tables accessed. That is very important. This slide was very important for us because we need to make sure that 7 out of 10 times banks engaged in the payment system, in the payment functions of the bank, and the payment card industry is highly governed by respective statutory law of the land. So the audit reports, like they're very expensive. Like when I say expensive, they're like they're highly respected reports. Than respect, I would say, like they're very key reports for the surveillance auditing of the banks. So reliability. So we want to put it very clearly. Like we can't say that there is a solution for all the problems. There are some problems are solved. Some problems there are dependencies. Like for example, power outages. When you're talking about data reliability, if you have a power outage issues, like then you cannot blame database system. So what you can blame database system, what you can't blame database system for. You can blame database system for power outages. You can blame for a hardware software. You cannot blame database system for a power outage. You can't blame a database system for a hardware failure. Software failure, yes, like database system itself is failing maybe due to a bug or configured wrongly. The human error, yes, like you can blame the application engineers. DBAs definitely allowing everybody to have the equal access. Like somebody went ahead other than DBA or table or dropped a table. Definitely DBA is responsible for that. Not everybody should be responsible for that. Data theft, to an extent, database team, database infrastructure operations team. National disaster, not completely responsible. And then how we can make systems which are definitely not going to be a single point of failure. So include, so these are like directly accounted to database infrastructure operations team, or DBAs, or data SREs, we will call them. Standby server investment, hard backups, testing and validation of the backups, archiving, delayed slaves. The backup tools, the backup options, like what are the backup in MariaDB? Like it's been like there have been several backup strategies. Each one of them carry their own importance. Like logical backup definitely is not recommended in a production online. It's not definitely an online backup. But then the logical backup is also important one, which happens in every bank every 15 days. That's a news for me. This is we do have customers in internet space also. They use logical backup because one, you can it's a highly reliable backup. You can edit the backup. Hard backup, which is an online backup. Incremental full backup. So these are like it's a direct go for us. Like here, does MariaDB support all this? Of course, right? You can use MariaDB backup. So MariaDB backup is in the Maria backup, which can do a full backup restore, which can do an incremental backup and restore, can do a partial backup and restore. Like, in fact, backup and restoration, our conversation used to go very fast because Maria backup provides everything, and the logical backup is supported. So, like I said, our most of the meetings are like we need to make sure that there's zero downtime. Technically, it was like debatable, right? And it is not possible. But then, functionally, from a database infrastructure operations, because it's going to be a database migration, database vendor migration from Oracle to MariaDB, right? So, how do you make a system which is going to be and this diagram was like was strong enough to convince the entire business. Functionally, the synchronous replication makes sure that there is going to be no transaction latency between the master and slaves. All the nodes in a replication infrastructure are going to be synchronous on a transaction level. The load balancer takes care of, which is MariaDB max scale, takes care of failover and archiving to build a very lean database infrastructure operations. That is, like, primary database is always retained lean. Max scale with MQ and T filters was taking care of archiving from the primary database cluster infrastructure to an archive database system too. Thank you. Thank you for giving me an opportunity to share the story, like how we spent our time to upgrade or migrate 3 of our largest ISVs with a great footprint in Americas and Asia Pacific to migrate from Oracle to MariaDB. Was interesting, a lot of learning, a lot of good, was worth effort. Like, though we spent a lot of time, which is good. It was a lot of learning, a lot of experience, and it was a good effort because we could migrate more than 8 banks in last 23 months to MariaDB. Some of the largest hospitals in Middle East, in Americas, and in Asia. You can write to me at shiv@minervadb.com. I accept most of my almost all of my LinkedIn invites. Follow me on Twitter, our Facebook page too. So we are hiring. MariaDB is hiring. Contact me if you're a DevOps guy, if you're a DevOps guy, if you're a database engineer. Happy to talk to you. Thank you.
Shiv, migration stuff. We're calling in from San Francisco, if the picture is any direction. Is that true?
That's right. That's right.
Welcome to the Q&A session. So the sky is not orange, or is it?
It's not orange. No, it's not orange.
Well, getting back to your migration thing, why migrate? Why do you think people are migrating to MariaDB? What's the reason?
Three important reasons are there. One is like the licensing complexity in the enterprise database systems space. Two is the open source and social innovation. Three is that the compatibility of MariaDB to web scale database infrastructure operations is much closer than traditional proprietary database systems platforms. So these are the top three reasons which compel enterprises to consider MariaDB for their web scale database infrastructure.
And when you say web scale, do you mean transactional? Do you mean analytical? What type of applications do you see people migrating to?
So now it is like the enterprises address the database systems more as data. They have a heterogeneous database systems infrastructure. They all converge in the sense that transaction processing systems are connected to the columnar database analytics infrastructure, and also they are harnessed by eventually consistent database systems. So when I call them web scale, if we look at, let's take most of our customers whom we talk to, whom we work very closely with, are very large banks who are traditionally on a proprietary database infrastructure like Oracle. For them, it is like they are more of a consumer-facing internet application provider for financial services. So for them, it's like web scale means like now my application is not just limited connected to the employees of the bank. Rather, every of the consumer of the bank is enabled to access their data, their transactions. So web scales means that. Yeah.
I was going to ask you what industry, what vertical is primarily migrating. And if I hear you correctly, you say it is fintech, but it's not just migrating existing applications. It's creating applications now that are consumer facing. Is that correct?
That's right. That's right.
So from what are they then migrating to MariaDB? Is it from MySQL or Oracle, or what is it?
So 9 out of 10 of my customers across Asia Pacific, Southeast Asian markets, Middle East and Americas, they are moving from Oracle to MariaDB. There are
Oracle, really, it's proprietary. It's not something inside the open source databases, but proprietary. So what's the compelling reason there? Is it licensing and the cost of licensing, or is it technology, or what is the reason moving away? Or
I would say, I would say that it's a combination of both. From a ownership perspective, like the cost of ownership of a database infrastructure for a web scale or for an internet application is too expensive on a proprietary software. Now, also from a maintenance operations perspective, I'm talking this from a technology maintenance operations perspective. If I'm building a database infrastructure which is data oriented than a database oriented one, then I need a very database infrastructure which is built for that scale. That leads MariaDB technically more compelling against several other options, even in the open source database system space.
So you're saying it's both of the above. It's the licensing cost, and it speaks explicitly because now when you create a system that is not just facing the employees of the bank, but also facing its customers, then the number of users is exploding, which has license implications. But then you're talking about the secondary costs of other things around it. So what are the other things around it that cost the most?
Now, if you look at building an observability and maintenance infrastructure for a proprietary software, a proprietary database system software, that means that you need to invest more on your monitoring infrastructure. Now, if I'm building something, it's going to be a data reliability infrastructure, which is like building a robust backup infrastructure. That means that more of an investment from from an operational perspective as well as from a budget of the bank. Now, when I'm looking at building a system for planet scale where the data volume growth rate is going to be by several times, then the cost complexity is one area. The operational complexity is like how many instances I need to monitor if I'm actually making my entire bank's payment systems enabled to my consumers. That means like operationally and technically, it's getting more complicated when I'm on a traditional proprietary software, which includes also the maintenance tool investments. Like, for example, monitoring, as I rightly said, monitoring availability, DR, everything. Whereas when you're looking at an open source, one is a cost component part of it. Two is like they are built to operate together, right? That means that the maintenance operations looks much leaner compared to a multi-vendor maintenance operations model of a traditional database infrastructure industry.
Okay, so the technological part of it contains a lot of orchestration tools, and you see these orchestration tools being available also for MariaDB. Those
Absolutely.
were very, very clear comments, very clear thinking about why people migrate to MariaDB, in what industry, and what the reasons are. Thank you very much, Shivi.
Thank you. Pleasure talking to you.
And now for Daniel Black of the MariaDB Foundation. It's all about you, innovation that matters.
Hi, I'm Daniel Black. I'm the Chief Innovation Officer at MariaDB Foundation. I'm presenting to you from Canberra, Australia. It's spring here, and like spring, a fertile, mature codebase with a vibrant ecosystem and a foundation keen on nurturing your ideas will help, and its own, will help deliver MariaDB Server innovation to you. But who are you? Who are the people to which MariaDB matters? And we start by answering this question by looking at the download statistics of our downloads page, on our new downloads page, and we see that most packages are actually Windows that downloads. And while it's certainly acknowledged as a big proportion, we know it's more than just that. So if we take a look at the source code where it starts and look at how it's distributed out, we know that a limited number of people actually use the source code directly. So how is it distributed and consumed? So the MariaDB Corporation and the MariaDB Foundation together produce a number of Linux and Windows distributions. The Linux distributions include CentOS, Fedora, Debian, Mint, which is basically Ubuntu, OpenSUSE, RHEL, SLES, and Ubuntu. And we've given instructions for some other distros as well. So on non-Linux distros, there's AIX actually produce MariaDB via Bull Freeware and AIX Toolkit. Homebrew produce packages for MariaDB for Mac OS, which also work on Linux, apparently. I haven't tested. There's FreeBSD, and there's Open Indiana as an Open Solaris-based distribution, which are all maintained with many thanks to the distribution maintainers there and looking after their community. Linux distros, in addition, produce their own packages, and Windows is listed here because it's got a subsystem based on Ubuntu, and all the distro maintainers there do an excellent job sort of packaging it up as well. The Ubuntu packages produced by MariaDB are distributed further and packaged up into the Docker library containers of MariaDB, based on the 2004 packages, and these are pushed to Docker Hub and as a container images for all the architectures that we actually distribute MariaDB for. If we look at how the Docker library image is consumed, it's pretty much any time you use MariaDB in a Docker Compose file, that will be using the Docker library file. most likely, without any setting changes. However, there's other uses such as like MailCow of Liston and Ibis as projects that just use the container directly in their projects, and you might be using it the same in yours. The Docker library can also be used on like Travis CI to test a number of open source and proprietary projects against the Docker container of MariaDB packaged up by the Docker library. The Docker library package of MariaDB is also consumed by OpenStack in their Trove product, which is their database as a service, which along with 11 other databases provides an integrated part of like the OpenStack infrastructure as a service platform. MariaDB is also used within other projects in OpenStack, like Keystone, their identity service. If we look back at like the Windows packaging, it gets packaged up by Apache Friends to XAMPP, which is a bundling of Apache, MariaDB, PHP, and Perl. And this is available for Windows, but also OS X and Linux. So XAMPP is currently maintained by Bitnami employees as a community contribution. However, Bitnami actually, as a VMware company, have a main product against MariaDB containers, and they produce a Debian rootless form of a container, which provides added security in the way it's packaged up. Bitnami also produce a virtual machine for download, and obviously that runs on VMware, but it's also available VirtualBox as well. Bitnami also provides some Helm charts for Kubernetes deployment of MariaDB, and that's used in a number of situations, namely Nextcloud, which runs their own Office environment, and this is one of the uses of the Helm charts. OwnCloud sort of forked off Nextcloud considerable number of years ago, and they actually use a MariaDB image based on Alpine, and they use that as a common storage platform for all their backend services. So Bitnami and Docker library aren't the only ones actually producing container libraries. Red Hat have got like their own container platform, which is freely available as well. Bitnami, through the cloud marketplaces, allow you to deploy MariaDB directly onto Google Cloud Platform, AWS on Amazon, and Azure. But you know, these aren't the only providers. There are a significant number of other providers that provide deployment to any of the hyperscale data centers of Google Cloud, Azure, Amazon, Alibaba Cloud, Tencent Cloud, IBM Cloud, or into service provider like ServiceNow. Bitnami's, I forgot to mention, was also produce either a single instance service, or you can deploy a multi-instance replication topology with minimal effort. And so this shows, you know, that even down these stacks, they're adding value and making it easier for users. There are a number of database as a service platforms that strongly integrate the infrastructure tooling into a really self-contained product, and these include like SkySQL, which is a MariaDB Corporation product, Amazon RDS, AsperaDB relational database service for MariaDB TX, and that's from Alibaba Cloud. And these are just some of the beginnings of a large competitive market producing MariaDB as a service offering. So as we sort of zoom out and we look from like the beginning of the source to the packaging, to the repackaging, up to the hyperscale data centers, we see the vibrancy of the ecosystem, MariaDB source code, to drive so much diversity in the ecosystem. This certainly isn't a complete picture. Even just scratching this itch on, the finding the source to large scale instances doesn't explore all the paths, and there's certainly a number of significant paths that most developers, users, and me don't even know about. But this is actually more than just a distribution chain. What it shows here is the degree of innovation already in the ecosystem. Each of these elements has taken MariaDB of a form, added value to it, and allowed you as a user to consume it at free or minimal cost. But what we see in the consumption of MariaDB is beyond just what it got delivered to you, it's how you use it. And we can start by saying that SQL is not like the terminal interface where you manually type SQL like Raymond Boyce and Donald Chayman and kind of envisaged 50 years ago. The SQL terminal approach contributed to the large portability of the language and its growth in adoption. And it still serves a purpose in like testing queries and scientific learning and one-off business analytics. Robert's Juniper kernel talk later talks about this interface and how it's been kind of reinvented as a Juniper notebook. However, for the most part, your applications actually consume MariaDB via connectors. These are language-specific constructs like connector C, connector J, Node.js, PyMySQL, ODBC, JDBC, PHP in a number of forms from MySQL to PDO, transform how a database is consumed by an application. And these provide a network layer and the marshalling required to talk to the database. And as an application interface, it's pretty much largely SQL at this layer. That may not be enough for you. There's other frameworks like Doctrine, Django, Drupal, Type ORM, Laravel, SQL Alchemy, but the list is really too large, and these provide a number of ways to make SQL look more like code or objects, as the case may be, or just as a database abstraction layer if you're targeting more than databases. And this layering sort of builds on the connectors underneath and provides an added value into the way you write your code. At the end of the day, some of you may be even using a higher level framework than that. Things like WordPress, Wikimedia, Joomla, OpenCart, or hundreds of other applications provide an extensible framework to their domain such that you can extend this and write your own application, even if it's largely a set of configurations of plugins and extensions. And these will just use MariaDB at the back end, but abstracted away. In addition to the application stack, there's a bit of infrastructure that's also needed around MariaDB. And the first set of this is around orchestration. In a sense, the distribution of packages is a kind of orchestration that allow you to reproducibly install the same product, but it also extends more to things like Puppet and Chef, more recently Ansible, Docker Swarm, OpenStack and Kubernetes, to name a few that provide a reliable, repeatable way of delivering actually the same MariaDB service into production. On the infrastructure side, to monitor databases, you need different tools like Prometheus, like Percona management and monitoring, PMM, like cluster control, like Monuing, to name a few that integrate with the server and provide meaningful statistics on what it's actually doing. To have high availability and horizontal scaling, there's additional products like MaxScale, HA Proxy, Orchestra, and Galera, to name a few that enhance the ability to move across multiple environments, be redundant against failure, and just to deliver more throughput for the same server. Backup tools from like MyDumper to MariaDB Backup are part of the infrastructure, and their compatibility needs to occur. In the tooling realm, there's GUIs like PHPMyAdmin, query analyzers, Juniper notebooks to MyCLI, MySQL Tuner, and all these provide advantages to make the most out of MariaDB and make it easy. And lastly, I want to actually cover like multi-user services. So things like Plesk and WebMin and VirtualMin provide like a management interface to MariaDB used by service providers that give multiple users a specific view of the database. Things like OpenStack and Kubernetes and OpenShift also actually provide a similar kind of granularity in giving users a large control of the infrastructure, and in theory in a way that sort of can limit the impacts on everyone else. And so by looking at like the distribution ecosystem, the application layers, and the infrastructure tools, each of these independent providers actually work hard to deliver added value to you that you can deliver on to someone else, i.e. your customers and users, who at the end of the day should be oblivious to the fact that they've got a transparently infrastructure stack that's powered by MariaDB underneath. Okay, so now that we've sort of covered, how it kind of expands as far as distribution and use, I want to actually take a little bit of time to focus on how does it start? So the server development of MariaDB occurs in development and test iterations, and every now and then out of these pops a release. And the process repeats. So for connectors that aren't strongly tied to the development of server, at some point in time after the release of the server, those connectors actually pick up new features of the server, integrate them into their connectors, and they push out a release sometime later. If we continue further down the application stack, we see that frameworks, in a similar way to connectors, will wait on a release of a connector, see what features it exposes, and then try to actually incorporate that into their product. And as we can see, even though that this is really transparent, it happens all the time. The APIs are backwards compatibility. So the development of the framework and the connector layers largely occurs asynchronously. How if we look at, new features, it takes some time to actually propagate through the development communities to get to you. And so what I'd like to, every now and then, bugs happen and they need to go back to the layer that introduced the bugs, and, it's software, it's not infallible. Bugs will get fixed, and that delays the delivery of new features down to you. What I'd like you to imagine for a moment is if the development process looked like this, that the server development occurs at the same time as the connectors development occurs at the same time as the framework development. However, because a lot of the connectors and the frameworks are open source. They've got a rather minimal environment to get them going, and they've got their own test suite. So why not bring those aspects of the test suite, clone them down in a continuous integration and testing, so that the development of new features can start to be tested against the framework at the same time as the connectors are being developed and the server is being developed. And that way, when bugs are actually found, they're actually found before the release. And yeah, this is what I imagine it would look like. This is all really very new as far as a concept. Would have liked to actually show you more, but for instance, here's what we've got as a PHP build environment. It's not too hard, it's not too complicated. There's a few dependencies. A Docker file definition is all it takes to define what's needed to build, and along with some volumes and an entry point that starts the build process. Now, on that entry point, it's a combined build/test script. Don't worry about looking at this too closely, but this shows us cloning down a source code into repositories, doing a bit of caching to make sure we're not doing it every time, checking out the stable and development versions of PHP. And if we look at how PHP actually interacts with MariaDB, there's two main interfaces, the MySQL ND, and there's the Connector C interface. And so both of these have to be sort of compiled and tested separately. And on top of these two mechanisms, there's a bunch of PDO connectors that are presented in a different way, so we test those too. And this is the beginning. We've started to, plan out on how to use this for other things and how to actually write a full stack of integration and testing. And, we're not writing the test suites ourselves or the test cases, but we'll use what test suites are out and include those as part of our development process. This doesn't actually apply to the application stack. It can equally apply to the distribution stack, and examples such as DB deployer and Docker library are things that quickly sort of package up and use MariaDB as a package and also have their own test suites. So those are actually perfect to integrate in the same way. We're not going to achieve, 100% coverage of these. However, with a careful selection of the communities that we want to test, we can pretty sure we've covered a significant portion of the server and of all the connectors in between. So it's likely that, even though we're not covering 100%, that the things out there are using the same interfaces, so they're going to be bug-free by the time it's released. Well, that's the plan anyway. So all this building and testing infrastructure is off BuildBot. MariaDB Foundation has its own BuildBot, which has been running a significant number of architectures and compilers for quite a while, and operating systems to ensure that MariaDB Server is well tested when it gets to you. So we plan to continuously expand the range of testings to cover a sampling of the ecosystem of the application stack, of the infrastructure stack, and of the deployment stack. However, there's another direction I haven't actually mentioned. MariaDB depends on compilers and libraries to build itself, and these continue to evolve in ways that, compilers that change the way they transfer source code to object code. Libraries continue to add new interfaces and obsolete old interfaces. And without CI on these, it's hard to keep track of. We certainly don't want the case where a new compiler generates the wrong code and a user's stuck with a database corruption. So, let's try to find these faults early. Kernels from like the Linux kernel, the Windows, BSD kernels to Illumos Open Solaris kernels provide new implementations, and the compatibility needs to be tested. Multiple file systems are provided by Linux, and as database performance is heavily dependent on an efficient file system, this should be something we're actually testing frequently to ensure that the performance on MariaDB isn't getting degraded or regressed, potentially through code that isn't our own, i.e. kernel code. Also, kernels provide newer features like libio uring that provide ways of doing IO better than what was previously provided. And we should have a testing ground for those and making sure that they've got a path into MariaDB code base, and that we're actually sort of testing those not only from a functional perspective, but also from a design perspective. Are they actually going to be doing something that is useful for us, and perhaps offer suggestions on how to do things better? So how else is MariaDB Foundation serving you? I initially mentioned at the start that we've created a new downloads page. We've done this by cleaning up a lot of the user interfaces on these, auto-detecting the operating system and architecture that you're running on. And so what this will give you is actually a server product with less clicks and less confusion. We've also expanded the use of mirrors, particularly on the RPM-based distributions, so you should be able to get a faster download. Because we kind of acknowledge and see that the distribution stack is really extensive, innovation that was provided here was an API of versions and URLs and checksums on how to get at least like the first layers of distribution out. And so these can be used further down the track and to trigger the distribution in a more automated way. MariaDB also works on assisting contributors, whether it be a minor fix to get OpenBSD fully working on MariaDB, or whether it's helping some contributors actually provide like an alternate existing way of achieving their goals that they didn't realize was there. And sometimes we help contributors get past the trickier parts of serverless implementation, like this Unix time zone implementation. So gave them tools to get past the task and allowed them to continue development and writing the tests, because, hey, everyone likes finishing a project they started with, but not getting stuck down on the hard bits. MariaDB works by connecting communities when we kind of notice a bug report, well, something that looks like a bug in one forum that isn't reported into the bug tracking of the server. So in these cases, we noticed something was wrong. We alerted the people that had the knowledge and the skills to fix it, and they got fixed really quickly. However, breakdowns can actually happen. In this case, the Docker library, what happened was MariaDB fixed a time zone initialization for Galera, which really hurt other users on slow storage hardware that were using the Docker library. I guess developers actually test and run on fast hardware, so sometimes they actually don't notice these kind of effects. This fix for Galera was only meant to be for Galera, but due to its bug, it wasn't. So this was corrected in the next release. And it from a MariaDB perspective, was like, okay, that's all fixed. That's solved all the problems. However, some of the people in the Docker library land knew it wasn't totally fixed, and there lacked a really clear communication to say what it wasn't fixed. There was communication in circles about which versions were fixed and which versions weren't. And so what we needed to do was, pick it up at a bug and do some more investigation. After spending a bit of time, we isolated the problem that there was a second transparent, well, non-obvious cause of the same bug, which was in 10.3. The crash-safe ARIA engine started to become the default of the system tables, including those that store time zones. And it doesn't actually work so well on slow storage, especially with 7,000 inserts of time zone transition, and each of these occur with an F-sync between them. And so what we saw is, large degraded performance on these. We were unable to get a fix or really write a fix for the next MariaDB release. So we pushed a workaround to the Docker library. And so before they pushed out their next MariaDB version release, they had a workaround to work with. In the process of actually looking through these bugs, we also improved the Galera InnoDB-based time initialization. And just looking at how Docker library uses MySQL InstallDB, we realized that it's a little bit dated and probably hasn't significantly changed since early MySQL 5.6 or 5.7. So it's in time for a revitalization. So were the Docker people, library people, happy with this? Their comment on the report that says 3 minutes down to 7 seconds was, pretty compelling. And so that was just a workaround, and work continues to improve this. And hopefully with the CI, we'll catch this sort of problem ahead of time. As I mentioned with MySQL InstallDB, it's used by a number of different communities, so I felt it was important to engage and write them up with a prototype and say, okay, this is how we're proposing to improve it. Does it cover all your use cases? And we've tried to actually make it fairly generic here, taking an extra file descriptor here so you can inject SQL into the bootstrap process, which is used certainly a lot with container-based instances, and certainly not the server installs where it was designed for. MariaDB helps out by helping users, whether that be on the MariaDB knowledge base, on Stack Overflow, on DBA Stack Exchange, on Reddit. Users come into problems, and they sort of need a bit of help and direction getting over things. So the MariaDB Foundation, people are looking at those forums to look for those kind of things. And occasionally on those things you'll see, bug reports and things that need to be fixed, or just ideas that need to be improved on the server to make it a better usable product. MariaDB also has its staff doing its own self-directed innovation, and Robert's Juniper Notebooks, I mentioned a couple of times, is a great example of this, and I strongly recommend you watch his talk. Another feature request I wrote, or feature improvement I wrote, was improving MySQL dump. So instead of dumping out system tables, there's a bunch of create MySQL.user insert into MySQL user. We output it as portable SQL, like create user. And this applies to other things like roles on servers and a number of aspects that we see throughout the MySQL system tables, such that they can be imported in and a lot more portable between the versions. And so I plan on getting this until the next release. So the MariaDB Foundation also significantly works on the knowledge base documentation. As you can see, it's pretty much all done by Ian. So thank you, Ian. You're doing a great job in making sure all the MariaDB features are explained in a way that's actually usable. The MariaDB Foundation also creates podcasts on various topics to make it easier for the users. And sometimes we're just running or presenting at a MariaDB Server Fest. So another idea I've had on the back burner for a while, but I haven't had a chance to implement, but I thought I'd just share it with you as an idea. Load data actually works really great until there are errors, at which time the user is stuck and needs to resort to either splitting large text files or a complicated set of sed commands to clean up the data as it goes in, or write a looser table structure so it actually accepts the data, or writing your own import array. And all of these are really painful alternatives for what's something that's meant to be quick and fast and automated. So Oracle's database has an SQL loader that has a bad kind of data file where errors in the loader are actually pushed out to this file. But I think we can do better than that. So in this example, I've got a database of my pets, their year of birth and their weight. Nice simple table with a little bit of data on my dog. A little bit of inconsistent formats on my dog's Jovi's weight, which is 30 kilos. So what we do is like the sequence storage engine, not to be confused with the sequences in general. The sequence storage engine uses the name of the sequence with an automated header, i.e. seq, to define the structure and the row elements in the sequence. So this was called table discovery, and it was a large bit of innovation that was written by Sergey Golubchik in 2013, and it allows us to do a similar thing based on the name. So a structure that I'd like to see is, say, a load data errors table that is auto-created, and what this has is things like line numbers of the source code, of the data file that is read in, the full line of that was read in that contained the errors, just in case you got a delimiter error. It's got a enum that describes which column had the error, and we've got error codes and error text to make it all readable. And then what we do is we include each of the columns that were in the original table, and we make them nullable just in case it couldn't parse them. But beside those, we put out the parsed broken up text that was part of the original CSV file. So for my pet database that loaded, if we extend the load data syntax to refer to this load data errors table, what we get is a table here that has one entry that contains that line number 2 has an error in the weight column for Jovi. It couldn't really parse the weight, but it had its original text form as 30 kg. And so what this will make it useful for is with really large data imports or scripted imports, that you'll get tables with something you can actually do something with. And you can do something with it in SQL rather than writing a scripting or a language around importing CSV files. Because, hey, you used load data because you didn't want to do that. If you've got any further ideas on enhancement to this, please make a comment on MDev 13046. And yeah, I mean, there's a number of concepts that haven't been explored. For example, if do you want more than one error table per for target table? Do you want like the file name introduced as one of the columns and make that a joint primary key? It's all possible, but yeah, tell us your ideas. Load data isn't the only thing that can actually generate a bunch of errors. Things like alter table can lead to lossing conversions, and maybe it's worthwhile to actually have some of those losses like captured, rather than them A, being either silently ignored, or B, your alter table failing halfway through and needing to roll back on that. Another cases where the feature of SQL's strictness can come a little undone is, say, in replication. That data pushed through from the master side to the replica side isn't always the same, or has the same effect. Table structures can be different, so maybe we want to capture those kind of errors in the same way. We also at MariaDB Foundation acknowledge there's a backlog of feature requests, and these we need to actually get through and deliver on the things that actually matter to you. We know by looking at the code base, there's other, fertile grounds for further development of the MariaDB server. The engine independent table statistics was written in version 10.0.1, and it provides the framework for choosing better optimal query plans on running servers, on running queries. The table discovery, like I mentioned with loaded data, has a number of different applications, and yeah, it's ready to use. Functions, as of, I forget which version, there's actually an aggregate features that is available. Additional authentication mechanisms are possible, especially since like 10.4 actually has the ability to do multiple authentication mechanisms that are actually possible for a single user. So there might be opportunities for enhancement or integration into other products and systems for that. Encryption plugins, which were written either 10.0 or 10.1, also are a rich avenue for providing ways to encrypt the storage of data. And there's standards like KMIP that might be something that's portable and ready to use in that respect. And these are just some of the ways that MariaDB delivers a better server for you. We want to ensure the ecosystem is compatible. We'd love to hear about your feature requests and bug fixes that you want fixed, so please vote on these. Please write up your ideas for new feature requests, or just talk to us about problems that you have with working with MariaDB and SQL in general. And we'll see, what can be done to improve those. We're happy to help you developing your own features, particularly if you want to actually make them available for everyone else in the server code base. And we'll use our collective knowledge to continue to make MariaDB better, because it's all about you. Thank you, everybody. Bye. Any questions?
Daniel Black calling in from Canberra, Australia. Welcome, Daniel.
Good evening.
Yeah, well, you live in the world of tomorrow with daylight already.
Oh, yes. Advanced thinking or something.
Yeah, so it's only fair that you are the Chief Innovation Officer. So let's look at innovation. I think what you've been saying here is partly that innovation, yes, it can be new features, but it's not only new features, right?
No, it's about, I guess, delivering the whole experience of a better product for you. So, whether that be the information that it's put out by the knowledge base about the helping you directly in forums, in Stack Overflows, and DBA Exchange, in helping you get those things out, whether it's producing videos to make you understand the new features that we're writing, even during this conference. In Sergey's talk, there was a few things that I certainly did miss and go, "Whoa, that's there." So yeah, the innovation's happening all the time, and part of it's getting it out to you. Part of our continuous integration is taking the most of the fact that we do develop in the open to make sure that we can test it against all the things that you're going to want to use it, and we're going to do that before it's even released. So yeah, there's plenty.
Some of your statements and trying to sort of group them into each other. I hear you saying that communication and interactions is a key part of innovation. So in the area of communication and interactions, how should one, as a user of MariaDB, benefit from our innovations there? What's the way to interact with us and communicate with us?
Right. So if you want a feature, ask for it. There's Jira. You can log in, you can search for features, you can either comment on an existing feature, say, I want this slightly better, slightly different, or you can just write your own new one to say, I have this business case, I want a way to do this, I think it should be like this, and we can actually have a look at it. Write a blog, show us why it's important, or but make sure you link that in the documentation, because there's a lot written out there. Right. And if you want to refine an idea, you can come on to Zulip and just chat to us about it.
Right. So I was just going to ask about that. So Jira is for very structured and concise and summarized information, either about the bug that you have, and we've heard Sanja Bielkin talk about how to write a good bug report so that there are chances to reconstruct it and tend to it. But you were saying Jira is also for documenting what kind of enhancement request would be good. But then Zulip, can you say something more about when and how, why of Zulip?
So, Zulip allows, the foundation from all around the world, but also other users, and there's a considerable number of MariaDB developers on there as well that are available at various times when they haven't got their head stuck in the code to, pop out and take a look at what ideas you might be having, or what troubles you are having, and be able to work you through those. Or even if you've got an idea that needs to be refining, sometimes it's we give you an answer, it's not what you expect, but it sort of does what you want anyway. So that interactivity helps, clarify and present options that might be quicker.
And I would add on that towards Zulip that the interactions we've had during this MariaDB Server Fest are typical examples of what the type of value you can get out of Zulip. So it's not to be looked upon as a cheap or free support desk, but it is a place to interact about high-level requirements and to understand issues better before you can put them into Jira as a specific request.
Yeah, for sure.
So then what about if I have a support request, or I need to know more about how to use MariaDB Server? For knowledge, where should I turn for that?
So there's the MariaDB knowledge base that contains a good reference material for how functions work, but it also has guides on why you would use something and what's the typical form of a particular function or feature.
You were talking last time we had this chat in Paris. Time flies, and so do we. You were talking about the innovation of our development model and innovation when it comes to migration, which is a topic that has gone throughout this MariaDB Server Fest, about cloud and hardware. But hey, I'm afraid anybody who wants to listen to that innovation needs to go to the YouTube recording of that one. It still is live, because I think time is out for this session. So thank you very much, Daniel, for your innovative thoughts.
Thank you, Kai, and thank you, everyone. Have a great day. Bye.
Thanks. The MariaDB Server Fest in New York 2020 is now over. And what a fest, what a feast it was. We're happy to have been able to interact with our user base in your time zone. As I said when we started, we usually talk to the developers of MariaDB Server itself. Now we've been talking to database administrators, DevOps, and developers of applications using MariaDB Server. That feels good. That's what the MariaDB Foundation is there for. We work on openness, meaning contributions of code to the MariaDB Server code base, but also on adoption, helping DBAs and developers to use MariaDB more and better. And that's what we'll be doing here in New York, which feels good. If we look at numbers on live streams on YouTube, counting the streams of this week, and we've been in Paris as well, we've had several thousand views and over 1,000 thumbs up, and I haven't seen a thumbs down yet. And these are really, really big numbers for MariaDB Foundation. We're grateful for the attention. Now, when we set out to have this conference, we came with a couple of innovations, and we stated them also in the beginning of this conference. Pre-recorded presentations was the core of that. And I think it worked out well. We didn't have glitches about connectivity in New York, but we had one big one in Paris. And that one worked out well. We had resilience, and as organizers, we had peace of mind. There was a connection from the Ukraine, which did not end up working. But the presentation by Valery Kravchuk, he delivered his original presentation without an issue because that was pre-recorded. Then the Q&A session, well, that was a bit of a heart attack inducing moment, but we had our hot backups here, so we had other people, Vincenzo Ciorbaro first and Monty Michalvidenius second, who took the questions and answers. All of that would have been much worse without pre-recorded presentations. Then subtitles, that was a huge advantage. I think many of you liked them quite a lot because we understood that quality does not correlate with ease of understanding accents, meaning the relevance of a speech, the significance of it or the insightfulness of the presenter, that can come from people who are not trivial to understand from a pure accent perspective. And subtitles can help a lot here. Pre-recording also means availability later on. Now you might say, Kai, you're making virtue out of necessity, but we do see this as an advantage. We've made the URLs with the presentations constant all across, meaning from the very first point in time when we announced the abstract of a presentation up until as long as the internet URLs exist, it will be the same URL from which you will be able to find the presentation, and not just the presentation, also the QA session for it, and the PDF if the presenter has provided such one. Plus a link to the Zulip chat. So Zulip chatting, that got, I think, over 1,000 chat interactions during the conference. It wasn't hard to register. We got lots of new people coming into Zulip. It worked out as we hoped. And the hope was that now, given that the presenter is already canned, the presenter does not have to concentrate on delivering the speech when you as a viewer see it. The presenter can concentrate on talking to you, on answering your questions while the presentation is still going on. We separated these different presentations into topics on Zulip chat, which meant then that things kept clean. So when one presentation was done, people approached that person, the presenter, at the podium and continued chatting, while in the next room, meaning the next topic, the other presentation had already had already started, and the chatting going on in the previous one did not disturb the presenter of that new topic. And these chats are still available on the net, and I've seen discussions that started during the presentation going on in that very same Zulip topic later on, which makes me very happy, because this means that the interactivity that we created during the conference still hasn't died out, hasn't faded out. And these chats will be linked for you from the individual presentation URLs for posterity for you to look at afterwards. So now that the conference is over, what will happen from now on? Well, first and foremost, the recordings are there on YouTube. The videos will stay there. The live stream, which is 6 hours per day roughly, will be chopped up into individual talks. And these talks will also get their question and answer video recordings separately uploaded for you to look. And these Q&A sessions are often a bit of a summary of the entire chat. It's not just something that builds further upon it. It is another view into the same topic. Speaking of YouTube, I encourage all of you to now please subscribe to the MariaDB Foundation YouTube channel. The reason being that we have other videos there as well, short ones, tutorials created just to be viewed at YouTube, not just recordings of talks. Another request for you is to share your thoughts over social media. Now, we created these links for a purpose, and you can, and that is for you to have an easy time sharing the links with your colleagues and friends. So we've done our best, and we will continue now during the end of the week and next week to make these web pages with the recordings and the abstracts as useful as possible, containing these pointers to the Zulip chat and to the PDFs and other URLs that are relevant to that topic. We're not done with that yet. We're not done in that sense with the conference. The web pages will be of the individual talks at this Serverfest will be the way to interface with this conference later on. And that's the recording, the subtitles, the Q&A sessions, the online chat. And these URLs you can then share. We encourage you to share them with the people that you think may have use of it. Over email, over LinkedIn, over Twitter, Facebook, WhatsApp, whatever medium works best for you. And then I ask you to stay in touch with us over Zulip. Now you know where we are available over Zulip. We'll keep the topics open. This is not a place for free support, but it's a place to chat amongst others. And it's a place for giving feedback to us and giving feedback to the presenters on each of those topics. Please also use our normal channels, meaning very often Jira. Use Jira to report bugs if you find bugs in MariaDB Server. Also use Jira to suggest enhancement requests or to vote on existing enhancement requests so that we know where we should direct our efforts. That's how we work. And it is, if you wonder, yeah, so Jira, where is it? It's not very hard to remember, jira.mariadb.org. It's easy to remember. So now a couple of thank you notes. First of all, thank you to the presenters for pre-recording the presentations and also for being here in New York over Zoom, answering my questions and those given over Zoom. And many of you were also in Paris, and some of you will be in Singapore and Beijing at the end of the week. You certainly put in a lot of effort for this, and we appreciate it, and the users of MariaDB appreciate it. I want also to thank you, the audience, for interacting with us over Zulip, for listening, for viewing, for your time and attention. And now I want to thank the MariaDB Foundation team that made this possible. First and foremost, the video editing team in St. Petersburg. Well, when I say team, I'm a bit joking because people believe it's a large team. In actual fact, it's a one-man team, Alexander Morozov, who does wonders and magic with videos. I also want to give a very special thanks to the overall coordinator and cat herder, Anna Videnius in Grankulla, Finland. I want to thank the schedule and subtitle master, Ian Gilfillan in Cape Town, South Africa. I want to thank the web coordinator and generic fire soldier standing in for Valeri Kravchuk and doing whatever needs to be done at short notice, Vicențiu Ciorbaru, now here with us in Grankulla, Finland, but usually in Bucharest, Romania, where he's supported by his webmaster, Andrea Hendea. And the rest of the MariaDB Foundation team, Daniel Black in Canberra, Australia, Faustin Lamler in Venice, Italy, Anel Husakovic, close to Sarajevo in Bosnia, Vlad Bogolin in Bucharest, and Robert Binder in the southern Romanian countryside. Now, this team in turn is very, very grateful to another group close to the MariaDB Foundation, namely our sponsors. And the reason, of course, being that we get our salaries paid by the sponsors. So thank you to our platinum, gold, and silver sponsors. Our platinum sponsors, MariaDB Corporation, Booking.com, Microsoft, Alibaba, Tencent, and ServiceNow. Our gold sponsors, Visma, IBM, and DBS Bank. Our silver sponsor, Automatic. You make the work of the MariaDB Foundation possible. In conclusion, we are happy, and we hope you are happy too. We got lots of interactions with you, but we want more, and we established a special topic for this on Zulip. There's a topic on Zulip called Conference Feedback to MariaDB Foundation. So keep your feedback coming on that Zulip topic. How can we increase your benefit from this conference? How can we help you use MariaDB Server more and better? What are your suggestions for our next MariaDB Server Fest? Timing, format, content? I'm Kai Arne, CEO of the MariaDB Foundation, traveling home from virtual New York. Thank you, and see you next time.